All
right, morning everybody. So how are you guys doing? Hope you're doing great. Hope you had a good week. Today we're working on seminar number 3 here. We'll be talking about some exotic options, at least kind of at a fundamental level. And then in seminar 5, we're going to kind of do some things with Black-Scholes with it, but only after we get to talk about log normal distributions, which will be seminar 4. So, but today, yeah, we got things with exotic options and risk neutral pricing, such a huge critical concept for today, such an important one. Hopefully I'll make it make sense and try to like supplement your understanding of why it's so important, what it is. And then we also talk about some things with like binomial trees, and yeah, we'll get into that. And yeah, I think we just got a lot of good things here to talk about. So hope you had a great break and hope you're ready here to learn some stuff today. So, all right, let's get started. So first, I'm just gonna kind of take a look at some of these exotic options, the ones that aren't, around so, or that they don't really talk so much about, but we do want to talk about it here so that you have an idea about what they are. And not about you, but kind of remembering some of the formulas for it. But hopefully, as we talk about these, you'll see that that there's kind of a nice way to remember some of these formulas, super logical. And then we're going to even look at how some might compare to some other ones, how like their costs, which ones might cost more or cost less. We'll see that. So, all right. So first one here, we've got exotic options. So it's the look back. So the look back option. All right. So a look back is kind of like what it says. You are given the ability to, at the end, sort of look back and see where would have been like the best or worst time for you to exercise. So it'll usually be something either about like the maximum that the price ever was or the minimum that the price ever was. But yeah, you're kind of given that ability to look back. So if it's a look back call versus look back put, and then there's the standard one where they don't give you the strike, but then the extrema where they do provide the strike, right? So sometimes this word isn't so important. Sometimes it is, because they might just say that you have this extrema or standard option. But most of the time, the thing to pay attention to is, did they provide the strike or not? Because that's the thing that's going to be the big factor here. So so the cool part is that it's just like the payoff is actually has the same sort of fit as the payoff for a call or a put. So for a call, we remember that the payoff for the call was S minus K. Well, it was actually the max of that and 0. But we're going to see that here, we actually don't need the max of this and 0, at least for this type, the standard one. Okay. Why is that? Well, so first of all, when we do these extrema, these look back options here, it's going to basically have the payoff of S minus K, but only we're going to replace one of these with the thing that's going to maximize the payout. We're either going to replace S or replace K. Now, because they didn't provide us with the strike, that's what this one is, this floating strike. In other words, it's not really certain, they don't know. So we're going to replace that with the thing that's going to maximize our payoff over this whole time. So we're either going to replace it with the maximum or the minimum. And you can think, well, which would I rather subtract off? The biggest number possible or the smallest number possible? And of course, to have the max payout, you want to subtract off the minimum from there. All right. So this is the payoff for a look back call, a regular look back call. And for a look back put, you might think, okay, it's K minus S. And again, we're going to replace the K with the thing that's going to maximize my payout. And so I'd want to take the maximum over the whole history and subtract off the current price. Okay, as compared to the extrema lookbacks. So here is S minus K or K minus S. But now here the strike is provided. So we're going to then replace the stock with the thing, the ending stock price with the thing that's going to maximize my payout. So here, I guess it would be max price over here. Now here, we're going to actually need this whole max of that at 0. So kind of like you normally see here for a call, that's usually max of S minus K and 0. We're going to need that here because then you can think of it like this. Someone could give you this just like super absurd strike price. Like you don't get the ability to look at this to pick the strike. They're gonna like provide you this strike. So if the strike turns out to be like super high, like if they actually pick some like really unrealistic strike, like $1 million or something like that, well, chances are probably the stock will never really go above that anyway to pay out. So so you don't want to lose money on something like that, but you will just kind of walk away. And if it never goes above that, then great, you just walk away, the payoff zero. Unlike this one here, because for this, the final price is definitely always larger than the minimum, right? That just is logical. It might be the minimum, but it's never lower than the minimum. Otherwise it would be the minimum, you know? So this one here will never actually be negative. So we don't even need that whole max of that in zero. We don't have to guard against some sort of negative payoff possibility. Okay, and then when we look at the put, we're like, okay, K minus S. Oh, if they provide the K, that means I need to replace the S. And I'm going to replace that with the thing that's going to give me the highest payout. So I'd want to subtract off the smallest thing possible. And again, they could have provided some super weirdly absurd strike. So I'm going to need to protect against the possibility that maybe the payoff's negative. So that's why we see this. So it's hard to just memorize like, okay, put is always, you know, max minus S or something. Well, it is over here, but kind of over here it's not, you know. So I think the better way to think about it is what we did, start with the original payoff, what you would expect for a call or a put. And then if they provide the strike, great. That means the stock price is the thing that's going to be replaced. But then if it's where the strike is not, if the strike is not provided, then that's the thing that you're going to replace with the max of the min. Okay. And then there's a question here. It says, do you include the initial stock price for a look back option? Not the initial one. Yeah, not the initial one, but the just the ending price. That's the only thing. Oh, sorry. So you mean in the minimum or maximum history? Yeah, you can always include the initial one. That is also part of the history. So yeah, I believe that you can use that as well. So yeah, good question. So okay, so there's just just kind of look back, and if we compare that with the shout and the the rainbow option. So a shout option is one where you can sort of like pick sometime before expiration to shout, call the order to lock in the strike or to lock in the payoff, and then but then you could still possibly end up with a better payoff because you'll allow it to continue all the way to the end. Now, with like in practice, you can kind of put as many options to shout as like during, like you could have one that where you could shout twice before expiration or shout 3 times. But I think on this syllabus, I think they just kind of say one where you can only shout once, lock in some payout, and then hope for some sort of better payout in the future. So sometimes what they'll do for the payoff. So for the regular payoff, you definitely would get S minus K or 0. So definitely you'll at least get, well, you'll never get a negative payout, first of all. So it's got to be max of something at 0. But then you'll also, if it pays off quite a bit at the end, you'll actually get that payoff like a regular call. But then it has this extra ability here where you'll shout at some point in the middle. So we'll let S star be that stock price. So in the middle, you actually will shout to lock in the payoff. So you'll lock in some payoff there, and you might get that, and that might actually be the highest payoff that you could get from this thing. We'll see. But usually in a problem, I think they would have to sort of give you some instructions about when to shout. Like you could say something like, oh, the first time the payoff is positive, or the first time the payoff is at least the premium, or something like that. So you could kind of think about like instructions to say, okay, I want to lock in so that at least I can, get back the money I put in, or something like that. But then if it kind of does better later, all the way at the end, you even get a better payout if that's possible. So that's kind of the benefit of a shout. A shout put would be basically the same thing, but just kind of, for the put. So it'd be like K minus S, or maybe where you shout, maybe same sort of thing. You've got some, oops, not ST star, but just S star. K minus S star, great. So you got, you could lock in the payoff there too. And that just means that, yeah, whichever one of those is the highest, that's the one you get. Okay, now question for you guys. Which do you think is more expensive? So a shout option or a look back, an extreme look back? Which do you think would be more expensive? And so we'll say here, we'll vote this for Y and that for N or something. Shout, just if you want to vote, or you can text it to me too, or chat it to me too, that's fine too. But which one do you think is more expensive? The Extrema or the shout? What do you think? Then you can think about like, well, which one kind of is better? Because that's the one, yeah, no, good. Okay, so we got some different answers here. Perfect. So it turns out that the Extrema is more expensive. Now, why would that be the case? So why would it be the case that the Extrema would be more expensive than the shout? Well, if you think about it, the Extrema gives you this sort of ability to look back in hindsight, and you know how hindsight's 2020. So we see here, probably if it's a call, the best place that I should have shouted was like here, because that gives me the biggest possible payout I ever could have gotten if I was able to look back, right? But maybe the instructions that you received were like, oh, okay, for the shout, maybe it's like, oh, okay, as soon as the payoff would be positive, maybe that's when you'd shout. So when we're looking at our picture, maybe that would be like right here, you know, or maybe like just kind of like right after that, somewhere in here, you're like, oh, as soon as the stock price goes above the strike, I'm just going to lock it in just to make sure I get some positive payout or something. Or I don't know, maybe you'd want it to be at least a certain amount above, you know, at least like $2 above or something. So as soon as it gets to there, you lock it in. But that wasn't the best place that you ever could have done it. But it was maybe a good place to do it. So the shout doesn't allow you to know about the future things coming to see if there might be something better, but it does say like, okay, here's a favorable situation. I can at least lock it in there. But there could have been a better one coming and you just didn't know it. so that's why the shout isn't as good as a look back, but it's still better than a regular call, a regular option. So and then a rainbow option is one that kind of deals with a spectrum of assets somehow. So it might be something over two different stocks, you know, like whichever one is higher, whichever one is lower or something. It's maybe a call or a put on that, the maximum price of two stocks or the minimum price of two stocks or three stocks or four stocks or something like that. But there's just several assets under play with a strike. That's a rainbow option. Okay. And then a couple more here that we're going to be talking about. Well, actually later today, we're going to be talking about some of these with the binomial trees. Okay, so we want to kind of, so if we understand them now, we can be able to see how to price them later. But these are just some that they'll even come up on seminar 5, where we're going to use the Black-Scholes formula to actually price these things. So they're kind of interesting that way. So we just want to see what are they, like, what exactly do these options mean for me? So, all right, so we're going to say, what information do we know at time 0, and then what happens at time little t? And then they're sort of compound in a way that, well, there's still going to be a little bit more to go because you're going to know some stuff here, you're going to do something here, but then that's going to sort of set you up for when it really expires. So that's what all 3 of these are going to have, this kind of idea. There's this sort of like compoundness to them. So, okay, so what happens? So with a chooser option, what's a chooser option? So you might think, well, I get to choose something. And the thing that you get to choose is at time t, you get to choose or pick call or put. Okay, so that's the thing you get to choose. Now, so the things that you'll have to know at the beginning are, well, you're going to know the strike. You're going to know the times that you're going to be doing those things at. And yeah, and those are the things that you're going to know. So then you're going to be able to choose whether you actually get a call for the remaining period or a put for the remaining period. So we'll talk about even like how do you make that choice and things like that. So, but so thinking back to our first day seminar, right? So we had a straddle. So you remember what a straddle looked like? So I thought of it like, person's legs, that's the upside down one, but how about a long straddle here? So it's one that makes the V and it has a certain strike. So which of these do you think would be more expensive, the chooser option or the straddle? So let's call this Y and this N. So yeah, which one do you think? Which one would be more expensive, the chooser or the straddle? Take a second to think about it. So which one is going to be more expensive, the chooser or the straddle? Yes. So a lot of people said the chooser, it's actually the straddle. Now, why would the straddle be more expensive? Thanks for voting. No, perfect. Thank you. So why would the straddle actually be better? Well, more expensive, cost more, or be better, or you wish you could have that one instead of the other one. However you kind of want to reason on it. But if you think about it, the chooser here, you're just going to have to pick one or the other. So it could be that in the long run, maybe you picked the wrong one. Maybe you actually, chose the call, but the stock plummeted. And so you really should have picked the put. But this one, you actually have both. Remember when we actually made it up, it's a call plus a put. That would be the portfolio, long in a call, long in a put. And so you end up actually having both of them anyway. So if it turned out that the stock plummeted, great, you're protected over here. If it turned out that the stock went up, great, we have it there too. So you didn't even have to make the right choice here. You still get the benefit of both. So the straddle will be better, but it'll also cost more, right? So that's the thing. Okay, forward start option. So a forward start. Okay, well, so this has this idea that you're going to sort of kind of start it a little earlier. You're going to give it a little time to kind of like fully get ready or something. So what happens? So here at time little t, what sort of thing do you do? Well, you're gonna lock in the strike. Okay, so you get this ability to kind of like, or this, it's not even an ability because you don't have a choice, but you will lock in the strike only at time t. So you won't actually know what the strike is at the beginning, but you can't lock it in to be whatever you want. There's a little bit of a rule to it. So here's the rule. So what will you know at the at the beginning? Well, I guess you're going to know if you have a call or a put for sure. You're going to know the times that you're going to be doing these things at. And the other thing that you're going to know one other thing, and you're going to know the fractional value of the stock price at this time that your lock-in amount has to be. So they call it, some books call it, they call it different things. I think the one that's most common is little f, and I like to think of that as like fractional amount. So it could be like 100% or 120% or 80% or whatever, but it's just some percentage or fractional amount of the stock price at that time. So this is the rule. The K is actually dependent on what the stock price time is at time little t. And it's actually just going to be F times whatever that stock price is. So if it turns out the stock price starts at 80, but then I don't know, maybe at time little t, it's up at 100. Well, then the strike will be locked in at some sort of percentage of 100. The percentage you have to determine at the beginning, but the actual amount that it'll lock into will just depend on what the stock is there. So you see how it's gotten kind of a little bit of a rolling start. Like you don't really know what the strike is until later, but then you lock it in, you seal the deal, and then you let the call or put continue all the way till its expiration. Okay, we're going to see what that means for us when it comes to pricing, but that's the idea behind it. Okay. And then a compound option. So a compound option here is where, well, so here it's like a call on, well, like a call or a call on a put. It's not a call on a stock. So that's what we're normally used to seeing, a call on a stock with a strike at a certain time. But the thing is here is that it's actually the underlying asset now is not a stock, it's actually a call or a put on a stock. so in here is going to be a call or put. And I could also have a put on that. And actually the outer call or put is it's going to be that expires over this period. So the outer call or put is going to be some option to buy or option to sell. The underlying call or put at this certain strike and at time little t. So the things that you know are at the beginning, we're going to know if we have a call or a put on, and then what on a call or a put. So, but we'll have an example here, and there's an interesting little nuance to these kinds of problems that sort of go against what you're normally taught to do for calls and puts. So actually two different little nuances. First one is that it's not a call on a stock or put on a stock, but it's a call on a call or like a put on a call or something. It's some sort of combination of calls on calls or puts on calls or puts. And then the other thing is that what actually happens at time little t might be a little bit surprising. So we're going to talk about that a little bit later. Now, the cool part is because this is a call or a put on a call or a put, in this example here, I guess we've got, it's really calls and puts on a put. So this underlying asset here would be a put. And if you wanted to be very verbose about it, you could say, oh, the put, the full amount, like the full kind of parameters of the put is that it's on the inside put is on a stock with a strike and a certain amount of time to go, this amount of time to go. That's the kind of underlying put you're really talking about. It's really a call or a put that's going to kind of be active over time little t to capital T. So if you wanted to write it all out, you could just write it all out like that. But the cool part is because it's a call and a put call parity works. And so we can kind of think about what we were talking about before, the general version of put call parity, is that this is going to be, well, the prepaid forward of the first thing, which in this case is that whole put at time t on the stock with the strike and t minus t to go, minus the prepaid forward on the second thing, which was little x, right? So, and we just want to know, well, what time period does the put call parity actually work for here? Well, because we're talking about this call and this put that are over this time interval from 0 to little t, that's the one that we're going to get here. So that's going to be our time period here. Notice how it's not over 0 to little t or even little, or 0 to big T or even little t to big T, because these calls and puts are really just only active for the first period. And then once those expire, we're going to have the ability to buy or sell a call or put. That's going to expire over here. But just the outer calls and puts, they're just available from 0 to little t. So sometimes the diagram helps. So I'll kind of always draw diagrams for these just to put the times in there. And when you're talking about it more generally, it's sometimes hard to follow. But this is the idea behind these. And like I said, there's a couple of little weird nuances to these problems that they're not really clear about telling you. So we'll talk about those as we go as well. Now, the big thing here for us, if we wanted to use put call parity here, this one's easy. The prepaid forward of, it's just a strike. So this is just going to be x e to the negative little r times little t. So we realize, yeah, that one, it's just over this period. So it's just going to be discounting that with interest. So x and then e to the negative r little t. But the big thing is, what is the prepaid forward of a put? That's the big question. And we'll get to that in, I think it's actually seminar 5. We'll talk about exactly what that is. But this is, again, remember how I was saying how it's like, oh yeah, we're going to be doing prepaid forwards of all kinds of stuff, stocks, currencies. You could do strikes as well. We're going to do even weirder stuff. Well, this is one of the weirder ones. What's the prepaid forward of a put? If I had a put all the way out here or something like that, how do I discount it? I don't discount it with interest because it's not a dollar amount, like how do I actually kind of think about moving a put backwards? That's really what this thing's asking. Actually, it's asking over this period, little t back to 0. But yeah, that's the big question. We want to know what actually, what is that? So, but we'll cover that in seminar 5. So you have to come back next week for that. So, All right, let's do a problem here. And again, if you have any questions as we go, please feel free. But yeah, we'll just kind of do one here. We've got some weekly stock prices for two different stocks here, and just kind of get some practice about how to kind of like evaluate these things here. Oh, question back here too. What does little x represent? And little x is the strike of the outer caller put, not the strike of the underlying asset. That's going to be K. But since these are calls and puts, they also have strikes. And their strikes, they usually denote as little x, and we're going to do that too. Now we'll do an example here in a little bit. So hopefully that'll help it make sense a little bit more. But usually this strike is pretty low, but the strike on the inside caller put, which is on the stock, is usually a lot higher. So that's kind of a good little rule of thumb too, that usually if it's hard to remember which one's which. So let's look at this example here. So let's kind of see, and let's see what we could get. We're just trying to evaluate the payoff for each of these different weird options here, these exotic options. So, all right, so following table gives us the values of stock price at the end of each week, okay, for 7 weeks, it looks like. So let's use these to find the payoffs for the following options. All right, so it's a pretty standard exercise, but I think I've even seen some of these on some of the resources. Like this could be an exam question, is just like, oh, here's this table, here's these couple of options, just what's their payoff? It could be something as simple as that. So let's see if we could do these without really memorizing a lot, right? So that's what we want to try to do. Like try to avoid like this formula sheet. You don't want that. Anything we can cut down on that's good. All right, so a look back call on S. Okay, so I know it's a call on S, so it should have the payoff of S minus K. Now notice they did not provide a strike for me, so that must be the thing that I'm going to be substituting. And I'm going to substitute it with the thing that's going to be my largest possible payoff. So I'd want to subtract off as little as possible. So, and they didn't provide the strike, so they couldn't provide some absurd thing. And the last stock price is definitely at least as much as the minimum. So I don't need the whole max of that and zero. So I can just kind of evaluate this as we go. So ST is just the final stock price there, so which is 67. And then the minimum, well, that means I'm just going to look back and, well, which is the smallest price that it could ever be. And so looking back, I guess I see that the minimum was a 66. So I'm going to say that minus 66. And so the payoff is 1. So nice. Okay, good. How about a look back call on S with strike of 73? So, okay, a look back call is S minus K. Oh, but now they provided me with the strike. So I'm going to actually have to substitute the stock for the thing that I look back and see what gives me the highest possible payoff. So I'm going to actually do the max. And well, because they could have provided me some absurd K, I guess I should probably guard myself against a negative payoff. So I'll just say it's the max of that and 0. Okay, so let's see what we got. Max of, okay, so for stock S, what's the largest that it ever is? And I got 72. Is that what you got? So 72 minus 73 and 0. Oh, and it's a good thing we put this guard in here, because this payoff would be a -1. So, but if it's really an option, then you shouldn't really have to pay for it, except for gap options. Sometimes those you have to pay. So here, just the payoff is a 0. Okay. How about a look back on Q? So look back put on Q. So put is K minus S, or I guess Q, we could probably say there, but yeah, K minus the stock price. And oh, they didn't provide me with a K, so that's the thing I'm going to have to provide. So that's going to be, I guess, here the maximum that it could ever be. And okay, great. So let me look at Q and let's look back and what's the largest that could ever be. And it looks like to me that's an 83. And that happened right at the beginning. And the minus QT, so that's the final price, 79. So that's a 4. Then a look back put on Q is strike 80. So again, so that's K minus S or Q. And oh, now they provided me with the strike is 80. So that means that I'm going to have to replace a value for Q to maximize the payoff, so I'd have to subtract off the minimum. But again, they could have given me some weird strikes, so I've got to sort of put that guard up against a negative payoff, but that's okay. I could just do that pretty easy. So the max of 80 minus the minimum at 0. So 80 minus, well, the smallest that Q ever gets. And I see what, 72? Is that what you got? So that gives me an 8. So any questions about those so far, the lookbacks? You okay with that kind of system of doing it where we're like, okay, let's write out the payoff, S minus K or K minus S. Did they give me the strike? If they did, great, I'll put it in, but then I'll have to substitute the stock for the looking back as to what was the biggest or smallest payoff. And then if they provide the strike, it could have been weird. So I just want to make sure I don't have a negative payoff. So, and you don't honestly, like, you probably don't even have to really write the whole max thing. Just realize that if you get a negative number, then it really is 0. So you don't really even have to write that, but for completeness, I did. And then if it's the kind where they don't provide the strike, that's the thing that you have to provide with the historic information. So, okay, all right, what about the next one then? Number E, so a shout put on Q with strike 75, where we're ordered to shout the first time there's a positive payoff. Now, honestly, that's probably not the best instructions, right? But okay, well, as long as there's some sort of positive payoff. Well, I guess we wouldn't want to shout if there's 0 payoff. I guess that would be the kind of dumb thing to do, wouldn't it? Because then it's like, that's just worthless, right? You don't want to do that. But anyway, all right, so it's a shout put. So because it's a shout put, we know that, oh, there's going to be this extra time that we get to kind of lock in a payoff. So I know that there's going to be this sort of 3 things that I'm going to possible payoff. So it's a put on Q. So it's going to be K minus the ending price, or K minus the shout price if there ever is one, and 0. So I just want the max of those 3 things. So what do we have? So max of 75 minus, okay, the final price of Q is 79. 75 minus, okay, the first time there might be a positive payoff. So it's a put, and what does the put hope happens? Well, the put wants the price to go down below the strike. So down below. So when was the first time the stock went below the strike? Right there. So I'm going to shout at that time and lock in at least $1 payoff, which is good. And possibly if it expired at the end with a higher payoff, that'd been great, but honestly, it was worse, right? So there, the payoff would have been a -4. So, okay, obviously we're not going to do that. So my full payoff here was a 1. Okay. So they were able to shout the first time there was a positive payoff, which meant the first time the stock was actually below a 75, which turned out to be that 74. Okay. Okay, so probably if it were me, it would probably be one of those where I'm like, oh, I want to pay, like, I want to shout the first time that the payoff is going to make it like more than the future value of the cost, possibly. Like if that's even the thing, that way, you know, you've at least covered your costs. And then maybe if it ever gets better later, you could do that. Like at the end, maybe it'll have a better payoff. But so maybe that might be a smart move, but it's kind of all strategically what you're after. So. All right, a rainbow call on the minimum of S and Q with strike 75. So what do they mean by that? Well, we don't have to get too crazy with it, right? It's a call. And a call is basically S minus K. Right? That's the payoff of a call. In this case, they gave us the strike was 75. So that's good. And then, oh, I guess instead of the asset, now they're going to do the minimum of S and Q. So they actually want the min of S, T, and QT. And because it's a call, we're just going to do the max of that and 0, right? So it's a call price. It could be that the strike would have given a negative payoff. So but I should never have that for a call, except a gap call. So you might have seen that, but okay, so we look at this and we're like, all right, I'm just looking at the minimum of those 2 at the end. So it's a regular call. It's not like a look back rainbow, possibly. I mean, that might be sort of a weird combination that you could do, but yeah, you could maybe do something like that. But this one just said it's just kind of a regular European call on the minimum of the two prices. So we look at the end and we're like, all right, I have to substitute in the minimum of the two prices there, which is 67. So I'm going to take that minus 75 and 0, and this one is 0. Now, probably this was kind of a dumb one to even enter into. Well, it might have been real cheap because I feel like it's probably not very good for it to pay off. But you probably, if it's a call, you would have wanted to do the maximum of S and Q. That would have kind of like maximized your possibilities in the future. If you're like, well, I'd rather pick the bigger of the two at the end, and that would be more advantageous for you if it's a call. And if it's a put, maybe you'd like the minimum, but that doesn't have to make sense. It's just, we just kind of follow what the problem tells us. Okay. All right, and then the last one here, a 7-week forward start put on Q. So it's a put on Q with the strike being 110% of the 2-week price. Okay, so here's our little F. This is really like F equals 1.1, that fractional amount. And they're saying, all right, we're going to let this thing get a rolling start. We're going to see what the stock does. And then in 2 weeks, since it's on Q, in 2 weeks, we're going to lock it in. The strike will then be 1.1 times the price in 2 weeks, which was 76. All right, so let's get our calculators out. Actually, probably the first time we need them today, huh? So 1.1 times 76 gives us 83.6. So that'll be the strike of the put moving forward. So my payoff is going to be the max of, well, since it's on Q, so it's like a K minus stock. So 83.6 minus the final Q price, which was 79 and 0. And that gives us what, 4.6. Okay, so just to kind of see how they work in practice, that would be kind of like what they would do, maybe a question like that. They wouldn't give you all these, obviously, but just maybe a couple of them, but just kind of wanted you to see how they work and just an example of that. And we'll come back a little bit later to some of these with the binomial tree. So it's good. So any questions about these, those payoffs? Pretty good. Okay, sounds great. Sounds great. Now, this is actually a really important example here too, because here, this is one about a compound option. So we want to, well, I just wanted to explain a couple of things as to like why we're going to do things the way we do here, even though a lot of times they're not very clear about what they want from you on a question like this. Okay. But basically, all right, so let's kind of see what we got here. So in the market, there's a 70 strike put on a non-dividend paying stock expiring January 1st, 2021. Okay. Risk-free rate of interest is 4%. Okay, no problem. So the put has a strike of 70 and it expires January 1st, 2021. All right, on January 1st, 2018, and then 2019. Okay, so I'm just going to put these on a little diagram here so we can talk about what's happening. So I've got 1/1/18, 1/1/19, and then 1/1/21. So really, probably I would prefer to think of those as like time numbers. So if this is time 0, that's time 1, and then this would be what, time 3, right? Okay, so we've got this. And so they're saying that there's this put with a strike of 70 that's going to expire all the way at the end here at this time. Okay, that's what the first paragraph says. Second paragraph says that on January 1st, 18, Jones purchases an option that allows her to buy the put in a year. So buy the put in a year at time 1/1/19. So an option to buy the put for $750. And the cost of that option, so the cost of the option that she's thinking about buying on 1/1/18. So that cost of that thing is $225. Okay, we'll come back to that in a minute. And then they're going to tell us here, okay, now what if you know on January 1st of 2020 or 2019, what if you know that the stock price here is 68? And then that means that a 70 strike 2-year put on the stock costs 835. Okay, so I'm just going to write that too. A put here, so I'll say a put at time 1. Okay, it's just reading the information from that last paragraph. So the put of on a stock with strike 70, a 2-year put from that point, if the cost of this thing is 835. Okay, that's just what they're saying there in that second sentence, or that third sentence there. And then they said here, if the stock price on January 1st, 2021 is 65. So the stock price here at time 3 is 65. And it says determine her profit. Okay. Okay, so we still have to talk about that middle paragraph, but as far as this is concerned, are all these numbers okay down here? A lot of times on these compound options, they're going to give you a lot of this information. So I find it helpful to sort of write it below my little timeline here. So I'll kind of write them, just some of that information. I'm just putting it there. I don't really know what to do with it yet, but I'm just kind of writing it down. And then I also know about this whole, I'm just going to tackle paragraph 2 in a minute here because I want to explain a few things. So far so good, right? Is this okay? Okay, now we still need to know, like, okay, what about this whole compound option? Like, what are we going to do with that? Okay. Oh, the other thing here is they said profit. So profit usually is something at the end, right? We always did like, oh, payoff minus future value of the cost. Profit is usually something at the end. In a lot of these problems, they actually talk about the present value of the profit. So keep that in mind. Sometimes they're going to want you to bring all the cash flows back to time 0. In this one, because they didn't say present value, we assume it's at the end. So they'll kind of like find out the cash flows at each time and move it to the end, right? That's what we're going to be doing on this one. Okay, so just keep in mind, just keep an eye out for that. A lot of times they want present value, but they could actually want future value. Just have to pay attention to what they're saying. If they don't say anything, they mean future. All right, let's tackle this middle paragraph then. Okay, so when we think of calls and puts, the kind of the quick way to do it is to think of like, okay, if the stock goes up, this thing pays, or if the stock goes down, if the stock goes up, a call pays, and if a stock goes down, a put pays. And that's a great way to kind of do these problems, just to get the answers out there, right? Just to get the answers pretty quick. We always can go back to our definition and think of like, okay, a call is an option to buy and a put is an option to sell. We still know that it's not really our primary way of doing problems, but we know that's what they are anyway. So call is an option to buy and a put is an option to sell. That's going to help us here on this problem because it says here, Jones purchases an option that allows her to buy the put. So what kind of option is that? Is that a call or a put? And since it's an option to buy, really they're talking about a call on the put. It's not a call on a stock, but it's a call on a put because it's an option to buy the put in a year. And the option to buy for a certain price, well, that price that they have the option to buy for, that's the strike. So this is really, so the compound option we're talking about here is the call on a put. The strike price for that call is $7.50 because it's an option to buy the underlying asset, the put, for a certain strike, for a certain amount. And that's kind of like the more literal definition of a call. But the cool part here is that just like we would think of it for a stock, we're actually thinking about this as just the underlying asset just isn't a stock anymore. It's a put, but that's cool. We don't care. It's just we're okay with sort of abstracting things a little bit. Okay. And then they said this option costs $225. So I'm actually going to say this, a call on put is $225. So they'll sometimes use that notation, COP, right? Call on put, just as a shortcut, but it really is a call on a put, $750. So if you wanted to be even more verbose about this, you could call it a call at time 0 on a put that's going to be at time 1 on the stock with strike 70 with 2 years to go at that point. The strike here is 750, and that call will last for 1 year, right? All I did was just kind of be a little bit more specific about this put. I kind of just sort of wrote out what it was going to be. What kind of put was it? Oh, it was a put on the stock with strike 70, and at that point it'll have 2 years to go. That's what we're talking about there. Okay. All right. So but you don't have to write it like that, but if you wanted to, that would kind of be the more expanded way to write it. Okay. All right. So the goal here is for us to think about the cash flows involved. Okay. Because if I wanted to know the price of the profit in the future, if it was just an initial cash flow and like one at the end, then we're like, oh, if I know how much it costs, or if I know the cash flow, you know, it's same information. But I would just take you know, the future value of that and bring it to the end, and then just combine it with the other one. Right. So now that I'm actually going to have cash flows at 3 times. So just a little bit more expanded version of a profit equation would just be, if I just know the cash flow at time 0, cash flow at time 1, and cash flow at time 3. If I know those cash flows, then I could just move all 3 of those to the future. Now, before we actually called this like cost. Well, it was like negative cost because cash flow and cost are negative, but we would sort of called it cost. But once there's kind of more than just the initial and the end, sometimes it's good just to kind of keep them all as cash flows and then just get them from there. All right. So we look at this and we're like, all right, what was my initial cash flow? So, okay, my initial cash flow is, well, I purchased this call on put. So I spent $2.25. So you could either say the cost was $2.25 or the cash flow was negative $2.25. Just for simplicity, we'll just keep everything as cash flow. So we'll just call it negative $2.25. No problem. All right, now the big question is, what's going to happen at time 1? And now this is a thing where they're not very clear about. And in this problem, they're actually not very clear about. Hopefully they are more clear as they move forward on these questions. But there's always this like, they're actually not very nice about this. So here's the problem. When we normally think of a call, so for this one here, okay, so for this call, we kind of think of like, okay, once the call expires, if the price went above the strike, I get the difference. And if the price was below the strike, I get a payoff of 0, right? And that's great. That's like if you were to sort of like cash in, just give me the difference, let's settle everything right away. And that's most of the time, honestly, what we do. On these problems, they're going to want you to not do it that way, but they're going to want you to do it a slightly different way. Also totally legit, but just something that they don't normally do. And this is probably why these problems sometimes cause trouble, because really it's an option to buy. So if we actually, at the end, really what we're doing is we're going to actually buy the asset for the strike. And especially with these compound options, because they want you to kind of go one more step with it so that they can see if you really know the whole process. Instead of just sort of cash settling here and being done with it, we're going to actually purchase or sell or whatever, depending on what the situation is. We're actually going to purchase for the strike if we can, and if not, we'll walk away. So what does this mean here? Well, all right, since it's a call on something with a strike 750, so I would love the price of the put to go up. I would love it to be above the strike, because since it's a call, I would love the asset to go above the strike price, so then I can execute the call. Now, in a year, what happened? Well, we actually found out that the put was 835. Oh, that's great. That's above a 750. So we actually are going to execute this call. And here's the thing that it might be a little bit weird. Normally, we would just get the difference, 835 minus 750. What's that, like 85 cents or something like that? And then we'd be done. We're like, oh, okay, I'm just going to make the difference and that's it. With these, though, they want you to actually kind of go through with the process. So what this means is this call, I'm going to actually buy the put for the strike. So what happens at time 1? I'm actually going to buy the put. For how much? For 750. Now, do you see why that's a good deal with this call? because the put's really worth 835. So I'm getting a deal on it because I had this call on put, I have the ability to buy it for 750. So I'm actually kind of like making 80 cents, 85 cents in a way. But for me, what's going to happen is, okay, I'm actually going to legitimately going to buy the put. I'm going to spend 750 for it. So my cash flow is actually negative 750. So it's not, so this might be the surprising part. It's not 85 cents. It would be if I just sort of cash settled. I could kind of buy it for 750 and then sell it for 835, make that difference. That's what we typically do. We just say, oh, I'll just make the difference and we're good. But they want us to keep going and they want us to actually do the buying of the put. So now in my possession, I actually have a put, and my portfolio then is I'm actually positive this put with strike 70, right? That's what my portfolio consists of now over this second, like years 2 and 3. So then when it expires, so now at the end of the third year, now we're here at the end. Okay, the stock price is now 65. So I want to know what's the payoff of this put. Well, the payoff of the put is the put hopes the strike or the stock goes below the strike, goes below 70. Did it? Yeah, it was 65. So that means that this put is going to pay 5. So my payoff is plus 5. So I'm going to actually have a cash flow or a payoff of 5 there. It's perfect. So then my profit overall, is going to be, okay, well, this negative 225, that's my cash flow at time 0. So I'm going to take that forward 3 years, and they said, what, 4% effective. So I guess I'm going to do 1.04 cubed. And then minus 750. So 750 forward 2 years, 1.04 squared. And then plus 5. It's already at the end, so it doesn't have to move. Great. And let's find out what this gives us. And I got negative 564. Okay, and that actually is the answer. So that's great. So I feel like the big weird part about these is, well, one of the big weird parts is what happens at time 1. When I exercise this outer option, this, in this case, this call, what happens? And it's a little different from what we normally do. And that's what kind of makes it confusing. But the process we're going to do here makes total sense. It's actually completely legitimate. It's actually more legitimate than what we normally do if you think about it, because a call is an option to buy. So really, when you exercise a call, you are actually paying the strike for the thing. They just immediately, sell it and make the difference. And that's why our payoff is always that difference of S minus K. but really what the call does is it gives you an option to buy. So we have that. Now I wanted to tweak this just a smidge. What if this was actually a put on a put? So that would be like an option to sell. Now, the thing is, though, is like we don't really usually say sell a put. What word do we usually use when we sell a put? We usually use the word write. So this would be like an option to write a put if the price goes below the strike. So I can write a put for 750 if the put was actually lower in price than that. So if the put was maybe like $6.50, I would exercise this outer put and I would write a put for 750. So since I wrote a put for 750, my cash flow would actually be positive 750 in that case. And my portfolio would be a written put. So my portfolio would actually have been negative P70. So then my payoff would have been a negative 5, right? So we would have to kind of think of it as like, oh, we're going to be short in the put. We're going to write the put. I know for me, I was always thinking, it's like, well, if I sell a put, does that mean I have to kind of like buy a put first, or like, kind of like, what's the deal with that? But no, it's just kind of like if you write a put, you can just think of it like that. Okay. The other thing I wanted to mention is sometimes they're going to make this more complicated, and we're not here yet, but they might provide you with some of the details about the stock. Like notice we didn't even use that stock $68 there. We just never even used it. But what they might do is they might actually have you compute the current price of the put using Black-Scholes. If you know the current price at time one and you know all the stats for it, right? You can actually compute the price of the put using Black-Scholes. That'll kind of compute out this price, and then that'll tell you if you want to execute or not. Now, one thing that is not real clear to me, and I actually don't know what I would tell you here, to be honest, but if you actually didn't exercise the put here, what do they want you to do? And the answer is I'm not really honestly all that sure. I think if it was me on a problem, I would just say like, oh, okay, I don't exercise the put or call this, whatever this outer option is. If it's not favorable for it and I end up walking away, I would actually terminate the problem there and then do the future value up to there, because that's where the kind of the problem ends. I didn't buy the put, or I didn't sell the put or whatever. So, but they're not very clear. And honestly, I think usually that doesn't happen, but they should be really clear about what they want you to do in the problem. So like, they're like, oh, if you exercise the option, you will hold that underlying, put till expiration. They should actually include a sentence like that, but a lot of times they don't. Okay, so keep an eye out for when you do these now. You'll probably see these, you might have seen them already, but if you see these questions, they should include a little sentence saying what you should do if you exercise this option. If you exercise the option, you're going to purchase it, and then you actually hold that underlying put until expiration. That's what they really should say. And they should even give you some other information like, oh, if you choose not to exercise the option, then you're done, or something like that. I could see you actually purchasing the underlying option for what the current price is. I could see that, but just not using the option to do it. So you could do that too, but I don't think I've ever seen that. Okay. But anyway, just kind of wanted to show you this, and even like what it means to have like a put on put or something like that too. Okay, but just want to give you this kind of way of sort of handling these. And again, a lot of times, actually, I don't know what proportion, but sometimes I actually have you do the present value of the profit, but that's an easy adjustment on this problem too. Okay. Any questions about this one while we're here? Feel free. I have a lot of questions usually about these, so as I work with students, let me kind of move this back to what it originally was. Okay, all right, good. Well, then let's go on to risk neutral pricing. Okay, now this is such a cool, such a critical kind of concept to understand here. Risk neutral pricing. You probably heard it a lot. Hopefully you understand it. I'll explain it here a little bit in case you don't. But what is risk neutral pricing? We always kind of hear this like, oh, the risk neutral probability of this thing, or risk neutral this, or you might even think, oh, risk neutral, I just replace alpha with R, or something like that. You can like, maybe that's how you think of it, and that's great. That is actually what you do, and it is actually that simple. But here's like the idea about this, right? So it's really about trying to find the price of something, and this is always when you use it, is if you're trying to find the price of something. And if we think about it, the price of something at what time is that? The price of something is always at time zero, right? So I would really want to know the price at time zero. So what I would really need to do if I wanted to find the price is, and it could be a call, it could be a put, it could be one of these like look backs, or shout options, or whatever. It doesn't matter. Any weird option, or even something about like a stock squared or something like that. Anything. The way that I would actually have to price this is I would kind of have to find out what is its expected payoff, or its like average payoff or something in the future, and then somehow kind of discount that to time zero. Now, the thing is, though, we've sort of learned about this, so I'm going to call this price. I don't want you thinking that's a put, but the price is expected payoff. And then I'm going to have to kind of like bring it back, right? The problem is like, it's not a fixed like dollar amount, right? It's kind of like an expected value. It's like an average value. So I can't just take it back with interest. I mean, I'd love to do that, but I just can't. Because if it's like a call or a put or something, it doesn't increase and it doesn't grow and shrink at the risk-free rate. It's not a fixed dollar amount. It's not like a bond, you know. If it's a stock or something, I'm like, I can't, like we saw with the prepaid forward thing, I can't just kind of take everything back with the risk-free rate. It just doesn't work that way. So the thing is, if we're going to do this in real life, we would have to find the expected payoff and then discount it by, well, the rate of return of the kind of thing that you're pricing. So they usually call that gamma t. So if it's 0 to time t. So this is what we would really need to do in real life. The problem is like, we really won't know the expected return of the option. This is the hard part. We actually don't know what that is. And it's actually an average expected return over this period. All right, so I'll put that here. This is kind of like average expected return of option. Let's call it an option, but it could be any derivative security, anything that derives its value from something else. But that's what we mean by this whole like gamma thing. It's that. So this really causes a huge problem, and we need some kind of workaround. So the workaround is what they call risk neutral pricing. Risk neutral pricing is actually a super sweet, simple fix to this. And you just kind of assume what's in the red box. So with risk neutral pricing, you just assume that every risky asset, every stock, every call, every put, every look back call, every shout option, everything actually has a rate of return the same as the risk-free rate. Everything grows at a rate of R. It's super boring. It's like kind of this alternate planet of like robots or whatever. It's where everything just grows at the risk-free rate. It doesn't feel very fulfilling, right? Some stocks don't grow better than other stocks. Every stock is risk-free. Everything is, it's kind of like transferring yourself to a risk-free universe, right? The cool part is that if I were to find the risk neutral expected payoff, so anytime we deal with risk neutral, we use stars. So the risk neutral expected payoff. And then since everything grows at a rate of R, now I can discount this with the risk-free rate. The awesome thing is that gives me the exact same price as if I would have priced it the real legitimate way if I actually knew the average expected return on the option. Okay, this is what they call risk neutral pricing. I can find the risk neutral expected payoff and then discount with interest. Right, so that's actually the two steps that we're going to need to find the price of some sort of derivative. We're going to find the risk neutral expected payoff at time t. And then step 2, discount with risk-free rate. Super easy. And then actually to find the risk neutral expected payoff, we actually would just replace alphas with R's. We're going to see this with Black-Scholes. Actually, this is what Black-Scholes did to find the price of a call and price of a put. They used this technique, risk neutral pricing. And we actually use it on binomial trees all the time. In fact, it used to be on the exam that they actually had true probabilities and risk neutral probabilities on binomial trees, but you don't really see that so much anymore. And that's why we always use like P star for binomial trees. I don't know if you ever kind of noticed that, like, why do we do P star? Because we're actually doing the risk neutral probabilities. So we're kind of transferring ourselves to like this alternate universe that's all risk neutral. Everything grows at a rate of R, and that's what we have there. Okay, now we're going to see that this is related to things that we've talked about before too. But do you get the idea, at least the basic idea? So it's just a different way to compute the same price. And that's what makes it so powerful. It feels weird, like, why does this work? And it's actually not very easy to see, but it's actually completely legitimate. And it's a great way to find the price of something. In fact, it'll be kind of our go-to way of doing it. In fact, when you actually do later exams and you'll see you do like Monte Carlo simulation, what you're doing is you're actually kind of trying to simulate values that you can kind of average out if you were in a risk neutral environment. That gives you some sort of idea about what you think the expected payoff is going to be, the risk neutral expected payoff, and then you discount those with the risk-free rate. So it's kind of neat. You sort of like try to simulate what the expected payoff would be by simulating sample possibilities. That's what you do with a Monte Carlo simulation. So, all right, so let's see a typical kind of problem that they could ask here for us. Okay, so they said here, a stock has a current price of 100 and pays dividends continuously at a rate of 2%. Okay, so the risk-free rate of interest is 5% continuous. Okay, that's good. So it's the E stuff. Following table gives 3 possible stock prices in a year, as well as the risk neutral payoffs of the options at that time. Okay, risk neutral, so that's good. So the second and third stock prices have equal risk neutral probabilities. Determine the price of the option. Okay, so we deal with risk neutral, and then they asked us for the price of the option. So it looks like to me, we're going to have to think about what's the risk neutral expected payoff, and then discount it with the interest. That's probably the kind of thing that they're doing here. So just have to see, how do we actually carry this out? Now they said here that the second and third stock prices, the second and third states here, have equal risk neutral probabilities. So I'm going to make one more, kind of one more table, or one more column here. We could label it risk neutral probability or P star, however you want to do it, but this will be the risk neutral probability of being in that situation. And they told us here that, well, the bottom two were the same, so maybe I'll just call those X. And since all of them have to add up to 100%, I guess the top one would be 1 minus 2X. Right, so because these are the only 3 possibilities, they all have to be 100%, and we get something like that. And so actually my answer, I won't be able to get it right this second, but my answer is going to be, and it's actually very simple, it's going to be the expected risk neutral expected payoff. So I'm going to have to multiply each of these payoffs by the probabilities, right? That's how we do expected values, right? We just do probability times value. That's back to exam P. And then I'll have to take that back to times 0. So I'm just going to go e to the negative r 0.05. And then it's all for 1 year, so that's good. Times the, well, maybe I'll just write out expected risk neutral expected payoff of the option. So this is going to be e to the negative 0.05 times, and then the risk neutral expected payoff is just going to be each payoff, so 140 times its risk neutral probability, 1 minus 2x, plus 0 times x, plus 516 times x. And if I knew x, I'd be done. That's my answer. And the reason this becomes a risk neutral expected payoff is because I'm using risk neutral probabilities to do it. So if they gave me true probabilities, which they wouldn't, but if they gave me true probabilities, I couldn't find the risk neutral expected payoff by multiplying the payoffs by the real probabilities. I have to multiply them by risk neutral probabilities. Okay. But this is actually going to be my answer. So my goal here is to find X. I need to know what is the probability of being in these states. And I'm probably going to use the stock somehow. I just need to know, like, okay, how do I actually use the stock for that? Well, remember, in the risk neutral environment, you say that everything's expected return is R. So even the stock, its expected return would be R. Okay. So, well, what does this mean? I could think about it one of 2 ways. I could think about it as taking, like, okay, my current price, and I can move it forward with its expected return, R, and that would give me the kind of like the risk neutral expected payoff. But I could even think of it as like, well, why don't I kind of do the same kind of deal I did over here, I know the price of the stock has to be the discounted risk neutral expected payoff of share of stock purchased at time 0, right? So the cool part is though, is that I actually know the price of the stock. It's 100. 100 is the current price. So that's kind of like here, price equals. And then for me, the same sort of thing. I'm going to take the risk neutral expected payoff and then I'll take it back with interest. Same thing. It's the same thing. Every this weird option, every stock, every put, every call, I can price them all the same way. Their current price is just the risk neutral expected payoff discounted back. That's it. So even this stock has to obey the same thing. And what do I get for the stock? Now I have to be a little bit careful here, but this is going to be e to the negative 0.05 times. All right, now you might be tempted to say 100 times 1 minus 2x. And if you were thinking that, great, we're just missing a little something, right? This is the price of a share of stock bought at time 0. And because this pays continuous dividends, 1 share of stock bought at time 0 will actually not be 1 share of stock in the future. I'm actually, the payoff of a share of stock in the top state would be 100, and then e to the 0.02. That's actually what 1 share of stock would grow into in that top state, right? It would grow into this many 1.02-ish shares of stock, and each of them worth 100. So I just have to be a little bit careful that this payoff was the payoff of a single share bought at time 0. How much would that be worth now? That's what this payoff is saying. Now notice how that's different from expected stock price, the risk neutral expected stock price at time 1. This would be a single share, but this one includes the dividends that you also would have gotten because that would actually pay off. Okay, so just keep that in mind, that sometimes they're a little subtle about that, but this is not really exactly the same. So we just have to be a little careful. But all right, good. So I'm going to take that times 1 minus 2x plus 105 e to the 0.02 times x, and then plus 110 e to the 0.02 times x. So I just have to include those dividends in there. That's all, but quick fix there. All right, so I think what I'm going to do is I'm actually gonna maybe I will kind of move over to the left-hand side. Maybe I'll move the e to the negative 0.05, so it'll be e to the 0.05 on the left. But then all these terms have this kind of like annoying little e to the 0.02, so I'll kind of move that over there too. So I'm actually going to say this is going to be 100 e to the 0.05 minus 0.02, and I want to write it like that just for a reason. And that equals 100 times 1 minus 2x plus 105x plus 110x. And I could easily solve for x now. So I'm going to have, I guess on the right-hand side, I've got what, negative 200x plus 105. So I've got what, 15x. And if I move this 100 over to the left, so let me multiply this all out. 100 times e to the 0.05 minus 0.02, and then subtract off 100. Let me actually just write that out a little bit more. 100 minus 15x, oops, sorry, plus 15x equals 103.045-ish, like that number. So I just subtract the 100, divide by 15, and I get that x is equal to 0.20303 ... Okay, now for me, I'm actually going to also store that into x onto my calculator. So I'm actually just going to arrow x with a box in it. And I already have the setup for my answer. I'm just going to kind of put that x into here, here, and here. So I'm actually going to, yeah, I'll just kind of think about making those what's in the calculator. So then my final answer is just going to be e to the negative 0.05 times 1.4 times parentheses 1 minus 2x. And then nothing in the middle, I got a 0 there, and then plus 516 X. Okay. And I got like 178, 1.7875. So 179-ish, right? $1.79. But that's actually risk neutral pricing in a nutshell. It's just that I'm just kind of moving everything back. That's all. But I have to make sure that I keep in the risk neutral environment. Okay, so when we come back to this tomorrow, when we do the log normal stuff, we're going to see that it's an easy thing to make sure that we're in that risk neutral environment. We're doing risk neutral probabilities to be able to give me risk neutral expected values. So it's actually super nice. I'll be able to kind of make one little tiny adjustment to put myself in there so that I can find the expected payoff in the future and then discount with the interest rate instead of some weird unknown rate of return for whatever item I'm looking at. So any questions about this one? It's a little weird because I've got these like different states and stuff, but yeah, any questions about it? Very good. Okay, good. Then maybe let's take a couple minute break, a few minutes back. Maybe we'll come back at like 5 minutes or so, and then we'll continue on. We'll go into our next section about binomial pricing. Okay, so we'll just sit tight. We'll come on back. All right, so good. So let's kind of go on to kind of part two for today, binomial pricing. And as I've worked with students, I found that a lot of them are pretty good with this in general. So I'm not going to spend too much time on well, actually, I don't really spend any time on the typical stuff, like just finding an American option or whatever. That's all pretty easy. It's all pretty standard. But I did put a couple of things on here. I put one with currencies just so that you could see that. And then an arbitrage question, I did that. But I also put on something about a tree with futures prices because I wanted you to see what happens with that. And then I also kind of put on here a couple of ways to price non-typical things like a look back option. If you saw the notes, you saw what I'm talking about, like a look back, a chooser, and a forward start. So how would you actually price those with a binomial tree, right? Because those are not ones that you really see a lot of examples about. And so I'm pretty sure you know all the basics. So some of this I'll go through pretty quick, but I did want to kind of present it in a slightly different way so that those other things will make sense. Okay. So first of all, we kind of see this is a 3-period binomial tree. We're okay with that. We can think of it in terms of multiplying by a fixed, proportion to go up in the tree. They usually call that U, and to go down in the tree, they multiply it by D. D is less than 1, U is greater than 1, typically. And so we get, a tree like this. If we move up 3 times, we're going to multiply by U 3 times, so it's U cubed. They might denote these slightly different. They might denote this as SU, so for the stock in the up position. Totally fine, you could do that. This would be the stock in the up position. So they might kind of denote it like that too. It just depends. You don't always have to use U and D. In fact, you'll see for me, I rarely use U and D if I can help it, because it's kind of like an extra step a lot of the time to find the U and the D, and it actually makes the formulas a little bit less clear. So that's the thing. I'm gonna just show you a slightly different way. Feel free to keep using the U's and D's, no problems with that. If you're comfortable, keep it up. But I wanted to show you a slightly different way for that. But the big thing is finding the number of ways out to a certain branch. And for that, we realize that it's just a combination. So to find out the number of ways to get out to each path, we usually do like 3 choose 0, 3 choose 1, 2, or 3. Or we could do it reversed, right? 3, 0, 1, and 2. That's fine too, whichever. But I just wanted to show why we think of it like that. And the 3 here is talk about the 3 branches. And the 0 in this case, I guess, would be out of those 3 branches, I could have gone up or down. Which ones did I choose to go? Well, since I chose 0, I'm going to choose 0 to go down. Right? If you would have called this 3 choose 3, then this would be the number of branches you go up. So I think that probably might be more of what they, actually, I think that's more of what they do, don't they? So 3 Let me label those 3, 2, 1, 0. So this number here is, you could do it either way, but I think the typical thing is to choose, oh, how many branches did I choose to move up? So out of the 3 branches total, I chose 3 to go up. And in that case, there's only one way to do that. I could just go up one way. There's only one path that takes me up 3 times. But in this situation here, out of the 3 branches, I go up twice. And so what that looked like, I could have gone up, up, and then down, or I could have gone up, down, up, or I could have gone down first and then up, up. So there's 3 different paths, depending on which of those 3 I chose to move the down. 2 times I chose to go up, and then 1 time I chose to go down. So I can count that. So if the tree gets longer, if it's like something weird like 12 periods or something, they might do something like that on a question. Maybe it's a monthly tree for a year, and you just kind of want to know a couple of the payoffs or something. Then yeah, you can kind of think about these combinations, and that'll tell you the number of ways to get out to anything at the end. Okay, just think about the number of branches there are, and then these combinations. And then this choosing is just how many times you either went up or down, whichever way you want to do it. Okay, so these will evaluate to 3, and that's a 1. They don't usually get bigger than 3 periods, but they might. The other thing is to get up to those, we think of, so here we have P star always for these trees. So P star is the probability, the risk neutral probability of moving up in the tree, and then Q star or 1 minus P star, that's the risk neutral probability of moving down. Okay, no problem, you probably already got that. And then to get the full probability of being up in one of these ending branches, if the path doesn't matter, if you just care about what happens at the end, then I'm going to have, okay, I went up 3 times and down no times. This one goes up twice and down once, and so on. And so we see that these are actually binomial probabilities out here at the end, right? Because I've got this coefficient here times P star to that number and Q star to the rest of it. So it's actually a binomial with n equals the number of branches. Sorry, the number of periods to the tree. And the probability of an up move is sort of like the probability of success in that case. Okay, so that's the idea here. But I can get to those. If the path matters, then, well, then I'm going to have to actually just do several different calculations for maybe one ending node. I'll have to do one calculation if I went up, up, down. That'll maybe give me one payoff. And then I'll have to do another one if it was up, down, up. That'll give me a second payoff. And then I'll have down, up, up. That might give me some third payoff. And then each of those 3 might be separate payoffs. So I might have to do something like that if the path is important. So something like a look back option, the path would be super important. An Asian option, right? An Asian option is where you average out the prices that lead to the end, something like that. That's another case where we're going to have to not just think of just the ending point, but the path that led out to that too. So I'm not just going to have a 3 times some sort of probability, but I'll have each payoff separate and then just do those 3 as 3 separate items. That's okay. No problem. We'll see an example of that as we go. Now, the thing that I wanted to just kind of show a little bit different idea about was finding out the constraint here. So the forward price, okay, so one thing that we might have noticed, and I wanted to leave this here, that was actually the forward price. The forward price is the risk neutral expected value of a stock. Now notice how that's not the expected payoff. I took out the dividends, right? So actually it's really this. That's the risk neutral expected payoff of a share of stock for each share of stock at time 1. The risk neutral expected payoff is that, but that actually is the forward price. Okay, so that's something that we've talked about before, the forward price, but this is a slightly different way to interpret it, that the forward price is actually found by doing the risk neutral expected value of whatever the thing is I'm trying to do the forward of. Okay, interesting, right? So, but again, a forward price was to deliver exactly one share, not like accumulated shares. So that's why I kind of have to subtract the dividends out, and this is just per share here at the end. Okay, but knowing that, actually, it's kind of interesting because the forward price is the risk neutral expected value of a share in the future at time H, which is just going to be P star times the price in the up position, and then Q star, or 1 minus P star, times the price in the down position. And so just kind of rearranging this, I guess I'd sort of distribute the DS here. So I'm going to actually take the forward price minus that DS there, right? So that's that top part. And then that's just going to leave me with a P star times US minus DS. I just divide that. So the missing thing here is forward price. So the forward price minus the up or minus the down price over the difference in prices. Okay, now that actually it's just sometimes they put the 0 on there, sometimes they don't. So I'll just kind of take it off, but it's, current price times e to the r minus delta h. To find that r, that p star. Okay, we get this. Okay, so that's the one that probably you memorized. I'm gonna opt for this one a little bit more sometimes, and I'll show you why I do that. But you also might remember this one here. If the stock has a volatility associated with it, then we can actually get this shortcut version. It's actually just the same. It's just kind of if we plugged in the U's and the D's into this formula, the ones that we get if we have volatility, we do that. It just kind of simplifies out, and we get this P star over here. So it's kind of neat. Now the cool part is here is that, well, if a stock has volatility, then we can kind of, like, if they provide for us the volatility, we can use this shortcut formula, and then it kind of gets us some of our stuff a little quicker. And then we had the price that you, or the thing that you, so if sigma is provided, u was e to the r minus delta h plus sigma square roots of h, and then d was e to the r minus delta h minus sigma square roots of h, right? You probably already know all that, so I figure you don't really need that. Now, what I wanted to do is, I wanted to show you something kind of neat with that. So if I just multiply these by current price, then notice that SE to the R minus delta H, that is actually the forward price. So forward price, and then times E to the sigma square roots of H. And this one down here would be the forward price, E to the negative sigma square roots of H. So it turns out that what has to always happen is that the forward price has to sort of end up between the up and the down position. If it's ever above the up or below the down, if the forward price is ever below, like outside of that, then there's going to be an arbitrage opportunity. And that's actually what our next question is going to give us here. But just as far as a binomial tree is, it just has to have the forward prices to be between those somewhere. Now, if the stock has volatility, that's the special case of this. It's a special case where the upper price is exactly 1 standard deviation above the forward price, and the lower price, the down price, is 1 standard deviation below the forward price. Now, I bring this up because I've asked some students, or I've worked with some students, that if they're given a binomial tree, they always try to use some sort of volatility with it, even if they don't tell you volatility at the beginning. But the problem is you can't always do that. It's not always true. For example, you could have a situation where the forward price is maybe higher than sort of like halfway. That's okay, as long as it's still between the two, between the up and the down prices. That's really all you need for the tree to be okay. But sort of if you use the volatility, you're kind of thinking that the forward price is like kind of exactly in the middle almost, right? But anywhere between is okay. So if they just provide for you maybe the U and the D, but they don't tell you volatility, you can't assume that the forward price is like right in the middle there like that. And you don't need to either, but I've kind of worked with students where they try to always put in some sort of volatility, but you can't do that. It just won't, and some of them just flat out don't work if you try to do that. So, but we're going to come back to this a little bit later, that the price in the up position is really just the forward price plus a standard deviation, and then the down price is the forward price minus the standard deviation. And that's kind of where we get our red formulas over here anyway. That's kind of where we get those. And if you substitute those in, that's where you get this thing out. You can kind of factor and cancel some stuff and end up getting this idea down here. Okay, well, so why do I prefer this over here? Well, there's actually two reasons. One of them is it's honestly less work. Okay, most of the time it's less work, because most of the time they don't give you U and D. I mean, sometimes they do, but usually they just give you the current stock price and then the up price, down price. But notice how here with this one, I already have down price, up price, down price. The only thing I have to do is find forward price, but that's not really that hard. It's just going to be current stock price and then times e to the r minus delta times h. So I actually don't have to actually find U and D. I can just put in those prices. And then, so that's one reason, is that it's actually less work. It's just maybe a little less familiar, but we'll do it today. And you can pick which one you like. Honestly, I'm totally cool if you still use that. Totally fine, no problem. But the other thing is that this contains information that sometimes gets lost if you use this one, and especially when it comes to certain arbitrage questions. Okay, so that's what we're going to look at now. We've got an arbitrage question that's going to utilize that version of the P star. Okay, so if you want to just at least keep that sort of in your back pocket for when they do ask you some kind of arbitrage questions, sometimes this is that kind of alternate version of P star is a good one to use. You can just use the one that you're used to for normal. That's fine. If you're used to it, it's no problem. Okay. All right. But anyway, so, okay, a 1 year, 2-period binomial tree is used to price American options on a stock whose current price is 100 and pays continuous dividends of 2%. Okay. The price of the stock at 6 months is either 102 or 98. The risk-free rate of interest is 8% compound continuous. Find the arbitrage opportunity, explain how to exploit it. All right, let's draw our tree out. Okay, current price is 100, and so it's a 1 year, 2-period tree. So I guess each one is 6 months, huh? Okay, so it's an American option. So we're gonna kind of think about, it's not a call with no dividend, so I can't just automatically assume it's European. But the cool part is that it doesn't matter that it's American. I'm going to see the problem here right away. I know the price is either a 102 or a 98. I don't really have much more information than that. I could calculate U and D and then kind of find out these, branches out here, but we're going to see that I'm not going to need that, because when I go to try to price P star, I don't know about you, but these kind of feel too narrow, right? The 102 and the 98, I feel like should be like 120 and 80 or something. But that's like, it's only $4 difference there. Like, seems something kind of weird. But all right, P star. So I'm going to use my formula where I'm going to go forward price. So it's going to be forward for half a year of the stock minus the down position and then up minus down. So notice how I didn't even need to compute U and D. I just got up position or up price, down price. And the forward price, all right, forward price is 100 e to the r 0.08 minus delta 0.02 times a half. And then minus 98 over 102 minus 98, so over 4. And let's see what we get here. So I got 100 e to the 0.08 minus 0.02 over 2 minus 98 over, okay, so I got like a 1.26. Now, I don't know about you, but that doesn't sound like a good probability. Well, I guess it sounds like a great probability, right? Over 100%. But the problem is, like, that's not a legal probability. And just for the reason why, this was the forward price, and I got like 103.04. So 0.045, whatever. So actually the forward price turned out to be higher than the top one. Like so this is the problem. The forward price didn't end up in the middle somewhere, right? Like it should. So this is the problem here. And that is going to create an arbitrage opportunity. Now, okay, so here is where we just have to figure out, like, okay, how do we handle this? So if I use the regular P star thing, it might not be easy to see how it relates, but because I use my P star formula, I can write, what did I observe? I observed that P star, which is the stuff that I had, was greater than 1. And my formula was that it was basically the forward price minus the down price, and then over up price minus down price. I noticed that that ended up turning out bigger than 1, which is a no-no for probabilities. So that's a violation. So I can just kind of rearrange this here, and I'm going to multiply this over to the other side here. So I get forward price minus DS greater than US minus DS. And this kind of makes sense because it tells me that the forward price was more than US, which was what we said. We said the forward price was higher than the up price. That's the problem. So what do we do to exploit our arbitrage opportunity? So I wanted to put this one on here because this is one important exception, no matter if you use my method or their method, or like, you know, your resources, moving things to the less than or greater than. This is like one exception that is important to know about, okay? And there's actually a good reason why this is true. Okay, so this one is going to work opposite what you'd think, no matter if it's you do it with their method or mine, whichever one. We're actually going to move things to the opposite side of the inequality that we normally do, and that's going to give us our portfolio equation. Okay, so I'm actually going to move this to the left side, and I'll explain why. But my portfolio would be to go long in the forward and short in the stock. So that gives me the recipe. Now, the big question is, why is there this weird exception here? What's going on here? But you'll see that it makes perfect sense, right? Okay. So the big difference here is, what time is this at? This equation here, is this time 0 or time t? Like time 0 or sometime in the future? And if you think about it, the up, the down price, the up price, forward price, all of that's future. Every single arbitrage we've done so far has been at time 0. But this one is actually at time t, actually in this case, time 1/2. So t equals a half, but it's not at time 0. That's the difference. Okay, most arbitrage, 99% of arbitrage questions are going to give you some equation at time 0. Every call price that we've talked about, every current stock price, everything was actually time 0. This is one of the only weird exceptions where it was actually at time t. Okay, and so because of that, this is actually like the payoff. And so you'd actually want a positive payoff, right? You would actually want a positive payoff there, right? And so that, so I would actually want my portfolio to end up with a positive payoff. And you can kind of go through this and see that actually this is the idea of what you would want. And probably you would want actually e to the negative delta h here because it's with the forward price. So remember, forward price is always, it's actually based on per share. So you would actually need to purchase e to the negative delta h shares in order for the risk to cancel out. So, but this gives you the recipe, and that'll usually get you through the problem is what you need. But it's weird if you actually try to think through it it sometimes feel like, okay, the forward price is 103, but I'm going to go long in it. So I'm going to go long in this forward, but I'm going to short the stock to do it. And sometimes that might not be so intuitive. Okay. So, but this is the right recipe. And if you actually did out the process, you looked at the cash flows at time 0, cash flows at time t, you'd see that this actually would give you a risk-free return. Okay. I just want to put this on here. 99% of the arbitrage questions will not need this, but no matter which method you use, you're going to run into the same kind of problem. Okay. All right. Okay. So the other way that arbitrage comes up is because remember how we said that, oh, for arbitrage, we would love to have some sort of like alternate way to create the same thing. Right? That's how we usually exploit arbitrage is we're like, oh, we'd like this alternate way to do the same thing. Because then if I can kind of find a different price using those alternate things compared to the price that it currently is sort of out in the market. And that's what arbitrage is all about. We were like just trying to find an equivalent way to mimic the same things as that is the thing that's mispriced. So that's where something called the replicating portfolio comes into play. Now, this is the other way to price things with a binomial tree. So with a binomial tree, let me go back here. With a binomial tree, there are always two ways to compute the price at time 0, especially for a 1 period. This is the easiest. For a 1 period, we could actually just do what we normally do, where we're like, oh, okay, let me find out the risk neutral expected value. So I'm going to take like P star times the call in the up position plus Q star times the call in the down position. And then I'm going to discount that e to the negative RH. And that'll just give me kind of like the current price of the call. Right. I would do that. I'd find, oh, what are the payoffs? Find out the risk neutral probabilities, kind of like we did in the problem before that with the 3 different stock prices. But yeah, here's 2 prices, but same thing. Each probability times payoff. Move it back with interest. That's risk neutral pricing. And for binomial tree, that's probably the way we're going to go most of the time. There is, however, this alternate method for finding the exact same price, but it's with something called a replicating portfolio. And for that, that's where you compute out, the delta and the B. And then you say, oh, this is just, delta times current price of stock plus B, same price, same everything. But the benefit of this is that this is called a replicating portfolio because it's going to give you, it actually mimics the payoffs, these 2 payoffs, the payoff in the up and the payoff in the down for like a call or a put, whatever those payoffs are. But it mimics those by buying or selling stock and borrowing or lending money. So this is a perfect setup for arbitrage. Oh, these questions they love this for arbitrage. Okay, because yeah, I've just got this, I've got an alternate way to create the same price of the stock, but I can create the same payoffs of the stock by using this idea here. Okay, so you may just kind of remember the formulas, these ones down here. I gave slightly different ones, but I'll show you why. But we'll actually derive it here because I want us to see how this works with forward or futures trees too. So, but the idea is you're just going to replicate some option. I put V instead of call or put, but it could just be either call or put. So we just put V for value just to keep it general, but it's the value of some option here. And well, if we make our portfolio to be plus delta S plus B, right? So we know that the cost and payoff have the same sign pattern, right? This is going to cost a certain amount and the payoffs are going to be those amounts, right? Kind of boring so far. And so we just need to know like, okay, how much is this thing going to cost? Okay, so what about this? If I went long delta shares of stock, how much is that going to cost? Well, that's going to cost delta times S0. So it costs that amount. And then the bond, well, it's just going to be B0, however much I paid for it. And now here, okay, so what if I purchased a share of stock at time 0? How much is that going to pay off? Let's say in the up position. Well, in the up position, it's going to pay, well, delta shares, but then times, well, each share now earn dividends, and I know each share in the top position, I know how much each share of stock costs too. So I just need to make sure to include both those. So it's going to be S in the up, but then E to the delta H, I need dividends as well, because I purchased one share at time 0. So in H, I'm going to have that many shares. And in the down position, it's going to be almost the same thing, delta S in the down position, E to the delta H. And then the bond will grow with interest. So I'm going to get plus original bond price, E to the RH. And then same thing here, E to the RH. Doesn't matter if it's in the up or the down position. The bond just grows with the bond. The up and down position changed the price of the option, or changed the price of the stock. And it also changed the value of the option too. Because what are those supposed to equal? Well, in the down position, I want it to actually pay off the exact same thing as the value of the option in the down position. And in the up position, I want it to pay exactly the value in the up position. So all this is to be able to find out, well, the current price, V0, we could call it. I'm really trying to find out V0 because the law of one price says that if it has the same payoffs, if the payoffs match, then the prices will have to match. That's the idea. So the interesting part is that I get actually 2 equations and 2 unknowns. So I've got the value in the up position is going to cost, well, this much. it's going to have to have the same payoffs. So those payoffs are going to have to equal. So the value in the up position is going to have to be delta SU E to the delta H plus the bond. So we call it B0 or B, whatever. And then here, this in the bottom position, then we get this price that's going to be delta S in the down position, E to the delta H, plus the bond with interest, right? And if you solve these, you actually get these equations, which look a lot like what you've had probably, no problem. And I'll show you maybe the difference that you might see, but it is actually just you're just kind of solving this system of equations. In this case, you're actually trying to solve for delta and solve for B. So those are kind of like your 2 unknowns, 2 equations, 2 unknowns. It's just some weird algebra to get there, but that's it. You're actually just kind of replicating the payoffs. The payoffs from the stock and bond are this, and the payoff from the option are this. You're just trying to replicate those. And it just gives you the recipe to be able to do that. You can compute out the delta and the B to be able to give you that out. Okay, now how do you usually see them? Well, you probably see them a little different. You'll still see E to the negative delta H. And I always like this because delta goes with delta and R goes with bond. So that kind of makes sense. But the way that you might see it is that, well, this one is probably maybe how you've seen it. Actually, this one I think probably wouldn't be different. Sometimes you might see S times U minus D on the bottom. That's okay, but I kind of like it like this though, because then it relates to the Greeks. Yeah, you did the Greeks and you're like, oh, the delta for the Greek, that was the change in option compared to change in stock price. It's the same thing here. Change in option compared to change in stock price. It's the same delta, exactly the same thing. But here, this one may look a lot worse than what you've seen it. So each of these, stock price and up and stock price and down, you could think of those as U times S and U and D times S. And then you could cancel an S out. And that might be what you've seen, where you have E to the negative RH. And then you just have a U minus D on the bottom and a U minus D on the top here. But we have V, D, V, U. So you might see that. That's okay. It's the same thing. I kind of just like it like this because usually the stock prices are nice and easy, and it's actually no harder on my calculator to do that. But they're the same. They're the same thing. Okay. Now let's see how we can actually do this in a problem, especially a crazy hard arbitrage question. Okay, so let's get to it. So for these formulas you've probably already seen, but I just want to put this here for what we talk about at the end of the seminar. Okay, so a stock is a current price of 100. Price in a year is either 115 or 90. So I'm going to say here, okay, stock price, current price is 100, in the future 115 or 90. Stock pays dividends continuously at 3%, risk-free rate is 8%. A 1 year at the money call costs $10. So, okay, so a call at the money costs $10. Okay, to me that sounds too nice and neat. It's probably never exactly $10.00, so I'm feeling like this thing is mispriced somehow. Okay, no problem, we get it. Using any amount of calls, stocks, bonds, determine the amount of money lent or borrowed in order to exploit the arbitrage opportunity. So someone I remember asked us on, maybe it was on the first day or maybe the second day, about like, how do you know it was just for one option or something? But here they actually said we could have any amount of calls and stocks. So there's a lot of flexibility here, but they wanted to exploit the arbitrage opportunity and has a positive initial cash flow of exactly $20. Okay, so now maybe each one is just going to, maybe each call will give me, let's say, a $5 initial cash flow. Every arbitrage kind of thing that I exploit, maybe it'll be like $5. So then I would need to do that for 4 of them, you know, to just sort of multiply it, expand it to be able to actually have a cash flow of $20. So here they're they're actually just trying to be real specific here about how much initial cash flow I have. Okay, but binomial trees, the 2 main ways to do arbitrage were the initial one here where there was a problem with P star. They didn't really tell me anything about a call or a put or anything. They didn't tell me the price. So I wouldn't be able to use the method I'm going to use now, the replicating portfolio. But this is one kind of arbitrage. And the other one is if they actually give me the price, now I need to replicate that some other way. So I wouldn't use the whole expected payoff and then take it back. I probably wouldn't use that here because I have an arbitrage question. So for me, I'm going to have to find out the delta and the B, because I want to make this replicating portfolio so that I can exploit it for arbitrage. All right, so call in the up position, call in the down position. So this is what I need to find these out here. So the call in the up position easy is 15 and the down is 0. So I'll show you what I do for delta. So delta is e to the negative 0.03. And then I just think of it as like kind of like the Greeks, change in call 15 minus 0 over change in stock 115 minus 90. That's all it is, just back to that. And that is, and here I'm going to actually have to store a lot of stuff in my calculator so that I don't go crazy. So, okay, e to the negative 0.03, and then 15 over 25 gives me 0.5822 whatever. I'm going to store that into X. And then the B, I know that formula too. That's just e to the negative R. So 0.08 times H. Okay, so 1 year. And then for me, here's how I'm going to do it. I'm going to do price minus price, 115 minus 90. And then on the top, I have those same numbers in the same order, but now I just reverse the.
Are those interest rates correct?
I'm sorry?
Did I mess up my interest rates?
Oh, I'm sorry. So yeah, so the first one was 3% for the dividends. And then the second one is 8% for the bond. Yeah, good question. Yeah, okay. So the risk-free rate. Good. So I got 0 here, 15 here. And yeah, so let's find out what this is. And then don't forget to store that one into X or A or whatever your calculator you're using. And I got here negative 49,848. And here I'm just going to be a little bit careful because so it's arbitrage, right? And here they're asking about lent or borrowed. So probably the answer choices are, you know, borrow this or lend this. And so I'm going to have to be very careful about sign. So if I just store this whole thing with a negative in for sign, I feel like I'm gonna mess up the sign somehow. So I'm actually just gonna store, in this case, I'm just gonna store the 49 in for y. So I'm gonna keep the negative out because I'm gonna wanna manually, like, I wanna see where the negative is on my own, right? So I'm gonna multiply this by -1. I'm gonna store that in for y, just because I know like the sign is gonna be some issue and I don't wanna mess up with that. So, okay, so this is what so actually what we see is that the call price at 100 should be delta S plus B. So in our notation, we actually have X times 100 minus Y. Let's kind of find out what that is here. X times 100 minus Y. And I got 8.378. So I'm going to store that into Z. I'm not sure if I'm going to need it, but I'm just going to kind of just go store crazy here. So, all right. So what does this tell us? Well, this tells us that the call should be priced 837 or 838, but instead in the market, it's $10. So I can actually do my arbitrage thing now, right? The thing that I always do, I can say that, okay, what do I observe? I observed that the call in the open market, which is 10, was more than this whole delta S plus B thing, which was $8, right? So actually, I'm going to put in my X's and Y's, but I'll keep the S because that is kind of like, I just don't want to keep writing down the number of all these things. So it's going to be X shares of stock minus Y dollars. And for me, this is a time zero thing because this is actually shares of stock you'd purchase, a bond that you purchase at 0 or whatever, and then the call that you would purchase. So this is all a time zero equation. This goes as normal, no problem. I'm going to move everything to the right side. So my portfolio is actually negative C plus X shares of stock minus Y dollars. Okay, so great. Okay, so this is actually my basic portfolio. And this actually gives me the recipe for arbitrage. In fact, I guess I know that so long as lend minus is borrow, I guess I know I'm going to be borrowing money to do this arbitrage. I just need to know, like, okay, what scale do I kind of need to make it? So I already know I'm going to borrow, which is nice. Okay, but we'll get to that later too. So, okay, first things first. I want to make sure that my initial cash flow is exactly $20. So how much is my cash flow right now? I guess I want to know. So let me find out cost, because I know cost is plus a call plus X shares of stock minus Y. And I could just, just same sign. So the call, oh, sorry, minus a call. Why did I say plus? Sorry, minus the call. So minus 10 plus X shares of stock is 100. And let me see what this gives me. And actually, you probably already know, but it is negative 10 plus 100X minus Y. Negative 1.62155. So that's good because a negative cost is good. Cash flow is just negative. So cash flow was a positive $1.62. Okay, so again, I kind of want to know, I don't want the negative to mess me up. So I'm just going to store this thing into, let's say T. Okay, so all right, times -1. So basically I realized that at this point, every one of these portfolios here will give me $1.62 at time 0. I just need to know now. I just need to kind of scale it. I just need it so that instead of being $1.62, it's going to be exactly $20. So the way that we do that is, like, I guess I'm going to need maybe like 15 of them or something. I don't know, like probably more than 10, but less than 20 of these things. So I mean, like 15, 12, 13, 14, 15 of these things. But I can find out exactly how many I'm going to need because I could just take 20 divided by that. 20 divided by the $1.62. And that'll tell me the number of these things that I'm going to need. So I'm going to do 20 divided by that thing in T. Okay, 12.33, oops, 12.3387. So basically that means that I'm going to need 12.33 of these portfolios, 12 copies of the exact same portfolio in order to make a profit, an initial cash flow of exactly $20. Okay, so that's what my real portfolio needs to be. I guess I just need to multiply this whole thing by 12.33, whatever, that number there. So if they ask me how many calls I need, I guess I need to be short in 12.33 calls. I'd have to purchase X times 12.33 I'd have to purchase that many shares of stock. And then I'd have to, long as lend minus borrow Y times 12.33 total in order to accomplish this arbitrage. So I would need to borrow this times Y dollars total in order for this thing. So let me just multiply that by Y. And I get 614.82. That's how much I would actually need to borrow. Okay. I already knew I'd have to borrow because I was negative. I was short in it. Long is lend, short is borrow. So we knew that we'd have to borrow. And I just need to get the right magnitude, and 614 is the right magnitude. Okay. So just some weird algebra there in that one, but not really too bad. But I wanted to show, yes, so sometimes with binomial trees, actually most of the time with binomial trees, arbitrage questions will be of this type, where they'll want you to use the replicating portfolio, right? Because you're trying to create something synthetically to mimic something else. That's exactly what arbitrage is all about, right? In some rare cases, they might actually have you do the probability might be above 1 or below 0. And so then you kind of use that other thing with the forward. So you could do that, but that one's much more rare. This one is more common. Okay. But it makes sense. It kind of fits with the things that we were talking about before too. Okay. Question about this one? Pretty good. Okay. Okay, good. So I wanted to do now a question with currency, just to show you, because we did currency maybe a little different than what you've seen before, but I wanted to kind of do the same thing here. And also another sort of cool property about trees, I think that you might find interesting. So, okay, so let's see what we got here. So currently 1 Thai baht can be exchanged for 4 yen. A Thai investor, so okay, 1 Thai baht equals 4 yens. And again, I tried to keep it sort of out of the US, just sort of two neutral things. A Thai investor is interested in purchasing a 1-year European put on 1,000 yen with a strike exchange rate of 3.125 yen per baht. Okay. All right, so I guess we could write that down here, right? It's a put, and it's a Thai person buying it, so it's denominated in the Thai money, baht. And it's on, well, this one's actually on 1,000 yens. And then the exchange rate is 3.125 yens per baht. So, okay, well, that's a little bit weird. 3.125 yen per baht. But notice that this thing has to be like baht per yen. So, and usually we like to see that it's like 1 yen here. So to me, it's just not real clear. So what I'm going to do is I'm actually just going to make this 1 yen. And I'm just gonna have to do 1,000 of these, that's all. And I just wanted to know how many baht 1 yen was worth. So in this case, it's a good thing we kind of wrote this out, because I actually need to do the reciprocal, right? I want 1 yen is how many bahts, right? That's what I really need. So I actually want to, I guess I'm gonna have to take the reciprocal. So I really want to know how many bahts per yen. right? For each yen, how many bots? So basically, I just wanted to flip this over. So this is true. You could even write it like this, that this equals 1 bot, same thing. But actually, I want 1 yen would have to be equal to how many bots? And then 1 over 3.125, however you want to do it, however you see it, 0.32 bots. So here, and I think someone asked me about this before, like, oh, what will they always give you the exchange rate kind of in a nice way? And they don't have to. So you have to be kind of keyed in on that. So which is great. And here it's like, okay, you could do it in terms of 1,000, and that would be like 320 bots, but might as well just keep it into per yen. Maybe this way it's a little easier anyway. So this is what we're after. We're interested in the price of this put. Okay. And yeah, we had a little kind of a weird hiccup here, but that's okay. Like we just deal with what they give us, just have to make sure that it makes sense. All right, now they say that they're going to be doing this whole 3-period binomial tree. They want to price a 1-year option. So, all right, well, let's do it. So let's kind of draw this 3-period tree. Say about you, but oops. Okay. All right, and well, we just know they said an up move is a 20% above, and each down move is 20% below the previous node. Okay, so they might say that in a variety of ways, but we're okay with that. All right, big thing is, what's my initial node here? And usually that's like current stock price, right? So for us, the stock, quote unquote, is 1 yen. So what would be the current stock price, basically, right? Current stock price would be how much currently 1 yen is worth. And for us, okay, 1 yen is actually 0.25 bots. So my initial node here is 0.25. And I also know that we're actually working in bot as our local currency. So that means like our bot is acting like the risk-free rate, but then our yen, so basically R is our bot and the delta is the yen. And that makes sense because it's like, oh yeah, the yen is sort of like the stocks rate. So of course that's like the yen rate. And then the bot would be like the rate for the strike. So that makes sense that that would be the rate for the strike. Okay. And I just know that, okay, going up and down, I'm going to multiply by 1.2 to go up, and down I'll multiply by 0.8. And just for sake of time, I did that already. So this is 0.3, 0.36, 0.432, 0.2, 0.24, 0.28, 0.16, 0.192, and then 0.128. All right, and now we want to put with strike 0.32. So basically put with strike 0.32 on this. And so, okay, well, I guess the put is going to pay as long as the price is below 0.32. But if you think about it, that's going to pay at all of those. And if this was a larger tree, that might be not very practical to do. So I wanted to show you one other cool thing here, that we can actually use put call parity. And I'm actually going to find the call price instead. So I'm going to find the call price for a bot on 1 yen, 0.32 bots in 1 year, because so the call price is only going to pay in this position, right? And then if I find the call price, I can do the call price, and I can actually do put call parity to find the put easier. Now, maybe in this case, it's maybe just easier just to do it outright, but I just wanted to show you this way that it still works. So maybe you could try it out that way too, or for homework later. But in the call here in the up position, well, the price is going to be, well, I guess what, 0.112. So the call would be that, and then in the calls for all these other ones, the call would be worth 0. So actually the call is going to be super easy to find. It's just going to be e to the negative, well, the risk-free rate. And for me, since I'm in bot, the bot would be my risk-free rate. So I'm going to go over a whole year. So the bot rate is 3%. So a full year's worth there. And then I'm going to have, well, just in this up position, so I'm going to actually have P star cubed times that 0.112 and then zeros everywhere else. The only thing I just need to find P star, but that's a pretty quick thing to do here. P star is, and we could think of it as, well, since they give me the U and the D, maybe I'll use that formula this time, 1.2 minus 0.8. And then e to the r minus delta, but I think for me again, r is my risk-free rate. I'm in bot, so that's going to be the bot rate, 0.3 minus 0.5. And then since each period now, these are all per period, each period is a third of a year, so I'm going to divide it by 3. And okay, I get, and I got 0.4833 whatever. So I'm going to store that in for x. And then I'm just going to use that here, x cubed. So I can find the price of the call pretty easy, e to the negative 0.03 times x cubed times 0.112. So this call, so I got 0.01227 or something like that. So that'll be the price of this, of the call. We want the price of the put, but the price of the call would be 0.122 whatever. I'll store that in for y. But now a quick put call parity is going to just finish this off for us. And it's actually probably, it might be easier than you think. So, because basically I'm going to have call minus put. So I got call y minus the put equals, all right, prepaid forward of the first thing. So in other words, prepaid forward of 1 yen. And I just have to think, well, what currency am I working in? And well, the call and the put both are bot denominated. So this equation here is in bot. So I just keep that in mind, no problem. But I want the prepaid forward of 1 yen. Oh, okay, so sounds good. So I'm going to have 1 yen and I'm going to discount it by the yen rate, 5%. So e to the negative 0.05. But the equation's in bot, so I just have to convert it to bot. So I just need to know how many bots per yen. And that's the current rate. So 1 bot for 4 yens, 1 bot, 4 yens. That's great. And now I converted it. It's in bots now. So cool. And then minus the prepaid forward of the second thing, 0.32 bots. So 0.32 bots. Well, it's already in bots. That's great. E to the negative bot rate then. And I get my put that way. So I'm just going to move the put to the right, everything else to the left, and I get my answer. So I'm going to get this thing minus 1/4 e to the negative 0.05 plus 0.32 e to the negative 0.03. And I got that the put was 0.85 whatever's. And it's bots, right? Because it's in bots. So 0.85 bots. But again, I really wanted the price of 1,000 of them. I'll put on 1,000 yens. So it's just going to be this times 1,000, which gives me 85.0118 bots. So the cool part is that you can do a tree like this. If it's a European option, that's fine. It's just, you can just do put call parity the same. You don't need like anything fancy for it. This is perfect. It still works. So you can sometimes use that to help you to find the other option, and then you can use the put call parity to find the one that you want if it's easier to calculate the other one out. Okay, and currencies are the hardest ones to do. That's why I kind of want to do one here at the seminar. Okay, all right, good. So now I just wanted to do, so for our last bit here, just have a couple of things. Just wanted to do some sort of weirder options for a binomial tree too, just how to price them, because I'm sure you guys are good with the other ones. So I have the same tree for the next three examples. I've already computed the P star because I don't want us to really work so hard with the computations, but I wanted us to kind of think about like, how would we actually price these things with a tree? And we'll just set up the answer. We'll set up the equation, and then I'll just give you the answer just because of the time, I wanted to look at these. And for some of these, you won't actually use the whole tree, which is okay too. Sometimes they'll give you extra, so you just have to be a little bit discerning with that. All right, so we basically have that. We got P star is 0.52, so Q star is 0.48, and they want to know the cost of a 1-year look back put with strike 120. Okay, so a put. What's a put? K minus S. And they gave us that the strike was 120, so I got 120, and then I would want to put in here, then I would want the minimum, and of course I have that in a 0, but so this is sort of the payoff that I'm looking for, and it's a 1 year, so I am actually going to use all 4 periods because the whole tree is 1 year 4-period tree. So I'm going to be looking out here, and I'm going to be looking for any time that the minimum value was less than 120. That's going to be when these things are paying off. So I'm going to need to know sort of like which path it took to get out to the end. So the price of this option is going to be, I'm going to find out the expected payoff in the future at time 1, and then just kind of move it back with a year's worth of interest. So it's going to be e to the negative 0.06, right? So that's the interest rate for the year. And then times now, okay, what is my expected payoff for the end? All right, so I need to look for, where is this thing going to pay? So I could start up top and I'm thinking, all right, if I'm in that node, will this thing pay at all? So for this, because it's a look back, I need to know over the course of the history there, did it ever go, was there ever a payoff? Is the minimum of those prices less than 120? And actually, no, right? They're all like way too high. So nothing pays there. What if I'm here? Is there any path that goes out to there that'll pay, or that goes less than 120? So I think, well, I could have gone up, 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 down, or up, down, up, or up, down, up. The lowest price that I ever get from any of those paths is if it goes through this 192. But even that's not low enough to pay. So out there, so this node will never pay either, anything. What if I was at 225? Well, okay, so what's the lowest price that I could ever encounter getting out to that? And I guess that would be if I went down as much as possible, as early as possible, which the best I could do, the lowest I could do would be 144, but that's still not low enough to pay out. In fact, the only nodes that will actually help this thing pay out are these two. And the only endpoints that I can get to through those nodes are here and here. And even that, though, that's not good enough because let's say for the 135, right? To get out to the 135, if I went up, down, 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 I didn't hit that 108. So not every path out to the 135 is going to pay. Actually, out of all the paths that go there, there's only one of them that goes through the 108. And that one actually will pay. So that one will pay 120 minus 108. So I'm going to have that. But there's only actually one way getting out to that node that'll do that. So I went down 3 times. So that's what, Q star cubed, and up once, P star to the first. But I'm not going to have that sort of like coefficient of 4 choose 1 or whatever. I'm not going to have that because that means all 4 paths gave me that. But no, this is path specific, so I'm just going to have this value. And then to get out to the 81, well, there's only one way to go out to there. It actually goes through the 108, which is good, but actually ended up even lower. So that's cool. So I'm actually going to have the payoff there would be 120 minus 81. and then times Q star to the fourth. And Q star, by the way, would be, the complement of that, so 0.48. Okay, and this price I computed earlier, 2.5996-ish. So you could compute that out later, but just for sake of time, as long as you get the idea about how to compute this out. Okay, so let's do another example, just to kind of look at it sort of from a different angle. So what if we're now doing a chooser option? So chooser option, so here's what it says. It's a chooser option on a 3-month option with strike two. So it's the 6-month chooser. So I guess in 6 months, I'm going to choose what? Well, call or put. And the call or put is going to be a 3-month option with strike 250. Okay, so here's how we're going to do this. Well, we need to decide at each node what I want the call or the put. So I'm going to have to know how much a call costs for each of these and how much a put costs for each of these. I'll have to actually evaluate them, but it's okay because if I'm at that node, I've got strike of 250. So I know how much a call would pay for each of those. So for, let's say, if we just looked at this one right here, I know that I'm going to have this like strike of 250 if I want to try price the call. It's going to have a strike of 250, so it's going to pay 250 here and 50 here. And actually, a call with strike 250 will pay nothing here and nothing here, so that's kind of nice to know too. But if I wanted to find the price of this call, I'm actually just going to take the average of those two prices and then discount it back. So that's how I can find the price of the call in that up position right there. So I'm going to call it that. I'll say call in the up position is e to the negative 0.06, right? That's a whole year's worth, but in this case, I'm just going back a quarter. And then I'm going to have P star times the upper payment, 250. So kind of like the normal thing that we would do for calls. And then Q star times 50. And just for time, I computed this out already. So this is a little bigger over here. So I got 151.71. So 151.71. So that's how much that call would be. And I could find, well, maybe since I have all the call payoffs, I can find out each of these calls. So this call here, how much would that one cost? Well, if I was in that position, I would average those two prices. So I would actually have the call in the up-down position would be, again, e to the negative 0.06 over 4. So I'm going to discount by 1 period. And then I'd have P star times 50 in that case, and then Q star times 0. And that price turned out to be 25.61. And then actually you kind of know what the last call is going to be, don't you? It's going to be the average of these two prices and brought back, but that's actually a no-brainer, right? That price is 0 because I'm averaging the zeros and taking it back. All right, what about the puts? Well, now I need to know how much a put with strike 250 will be, because that's what I'm trying to think of, like, well, do I want to choose the call or the put? Which one is going to be better? So a put, how much would a put pay in each of these scenarios? So in the top one, well, the put's going to pay nothing, nothing. Okay, with strike 180, what would the put pay? I guess 70 now, right? And the last one is, well, 250 minus 108. I don't trust myself, so I'm just going to compute it out. 142. And we're just going to compute those put prices the same way. So the top one is going to be the average of those two zeros and brought back, but we know what that's going to be. It's going to be 0. the put in the up down position, e to the negative 0.06 over 4. And then I guess there I'm going to have p star times 0. So now I'm just kind of thinking of this little triangle. And so that's what you do with these. You kind of forget the rest of the graph. You just look at if you're at that one spot looking forward. And so I've got that and a 0 or in a q star times 70. And I got 3310. And just for sake of time, same thing on the bottom calculation, but I got 10300. Wow, that was kind of an interesting one. So now we're going to see, so for that last one, it would just be the average of the 70 and the 142. You guys have probably done that a million times. So just kind of computed it analogously. So now here's what I do. Now I choose at each of those which one to pick. Now, how do you think I'm going to choose it? Well, of course, whichever one has a higher price, right? So I'm going to choose the call, choose the put in the middle one, and choose the put on the bottom. And now to find the final price, I'm just going to take these back. Right, and don't forget to multiply the middle one by 2 because there's 2 paths that could get you out to there. And there it doesn't matter the path at that point. So then finally the price is going to be, well, e to the negative 0.06. Now I'm actually going back 2 periods. So I'm going to go half a year. And then I'm going to have p star squared times that top price, 2 p star q star for the middle price, and then q star squared for the bottom price. And all of that gave me 78,875, something like that. And you can check the math later, but that's the right process here that we want. But kind of neat, right? So you're actually thinking about, well, what would I do and how do I discount that back? And you get kind of like sort of these like mini binomial trees within a binomial tree. Okay. All right, let's do one more of these weird examples here now, a forward start option, and see how this helps us. Okay, and again, just kind of keeping it straight where you're at, looking forward, what kind of tree is that? Okay, so example 9. Now we want a 3-month forward start option. So I'm going to give it a 3-month running start. And then at that time, I'm going to lock in the strike at 87.5% of the price then. Okay, so then I'm going to say here that the strike for each of these is just going to be 87.5% of those. So 0.875 times 320 is 280. And 0.875 times 192, 168. So once I get to that point, depending on the node I'm at, the strike will be different, but that's okay, no problem. But I know that the strike is going to be locked in. And then they wanted a 6-month put from there on the 3-month price. Now, they're actually not very clear if they want you to use the 6-month total or 6 months from here. So, so they would have to be a little bit more clear. I was intending for it to be like 6 months from there. so sorry. It should hopefully be clear when they put it on there. But there is, it is understandable if you're like, well, do I want 6 months from the beginning or 6 months from there? But we'll go 6 months just to make it a little bit more complicated. Okay, but let's say I'm in this this top node now. Well, I'm only going to reach these 3 nodes from there in 6 months. And so I just want to know, all right, this put price, the cost of it's the put with that strike. So I can think of if my strike is 280, how much would the put cost here, or how much would the put pay here? And it's, well, nothing there, nothing there. But the put here would pay 100. So what I'm going to do is I'm going to actually take those 3 back to that node of the 320. I'm going to take those 3 back and find out how much the put would be worth at that point. So I'm gonna say put in the up position is e to the negative 0.06, but for that, it's a 6-month deal, right? Those 6 months. So I'm gonna go back 6 months. So over 2. And then, okay, great. I'm gonna have p star times 0, p star squared times 0, 2 p star q star times 0, and then q star times 100. And again, I did this already. It's 2236.
A Q star squared, no?
Oh, yes, perfect. Thank you so much. Thank you. Q star squared. Thank you. Great. And then, yeah, I guess if I'm in the lower node, then I'm going to do the same sort of thing. How much would my put be worth? But in that case, I only reach these bottom 3 here. But again, the strike is different. Strike is not the 280. Now the strike is 168, right? Because the forward start would have given me a lower strike in there. So, but it's still at the 300, it pays nothing. At the 180, it pays nothing. But now at the 108, it's going to pay, well, actually 60 now. So I'm going to have almost exactly the same computation above. So I'm going to say put in the down position is, and just for sake of time, it's going to look like, well, e to the negative 0.06 over 2. I'm still going to have actually p star squared times 0. I'm still going to have 2 p star q star 0. And then I'm going to have q star squared times, well, in this case now 60, because that's what the payoff was now instead, 60. And actually, it's going to just scale it really nice. It's just going to be 1342. So 1342 there. All right, now what are we going to do with this? Now here, we're going to take these two put prices now, and I'm going to take their average and bring them back. And that'll give me my final answer. So my price is e to the negative 0.06 over 4, because I'm just going back 1 period now. And it's going to be 2236 times p star, 1342 q star. And it's going to be like basically 1780. Okay, but again, don't worry about the calculations, but the sort of the idea, the mechanics, that's what we're after here. We're bringing it back. Okay, so we could just kind of think again, what does this thing do if I'm in that if I'm in that particular node? From node to node, it might give you different values, but that's okay. Just kind of think of if I'm there, what would I need to see in order to be able to find the price at that point? And then you might have to sort of do these compound options in 2 steps. Now, I haven't really seen a lot of examples like this, but I feel like this is a totally fair question for them to ask on the test. I feel like this would be a great question for them to ask, one of like something like this. It would probably throw a lot of people, they probably wouldn't expect it, but you guys can expect, like, at least you guys don't know what to do if you get a question like this. All right, last thing then, just real brief. I don't want to spend too much time with this because the futures trees come up, but they're not like as much as the other ones. But there's one important thing to note about a futures tree. I just kind of wanted you to see why they tell you to do the things they say. Like they say, oh, just put like delta equals R or something like that. They kind of tell you that. That's okay, but it's kind of not completely correct, but it's like kind of a good rule of thumb. But the key here is to know what the forward price of a futures value is. Like, what is that? And again, for F, we really kind of mean like F0, right? F naught. So current price of this futures. And the interesting thing is that it's actually just the current price, right? Okay, the current futures price, because the futures price already is the forward price. And so the forward price of itself is itself, right? So that's kind of the idea here. And because the forward price is really like the price that you imagine that it's going to be in the future. That's what they're saying. So if everything goes as planned, that should never really change. It's kind of like if you have your GPS, you're going to Starbucks or you're going somewhere and it says you're going to get there at 3 o'clock. You know, it might be 2 o'clock now. But so that's sort of like your price that you are, or the price, the time that you're shooting for. And as you go along, if everything goes as planned, that number doesn't change. It's going to stay 3 o'clock, but stuff could happen along the way. It might go to 3:02 or it might go down to 2:58, depending on what kind of driver you are, I guess. But I mean, it could fluctuate. By the time it actually get there, it might change, but that's what the forward price and the futures price are, is that they're kind of like your best guess now as to what those are going to be. And that shouldn't change no matter where you are. But with a futures tree, yes, that price could change. And if it changes, that's fine. What should we expect? That's what a futures tree is all about. Now, the nice thing is it's a perfect parallel back to what we did with the stock price. Now, if you recognize that, because then the forward price is the current futures price. So we actually are looking for that. And it's actually just going to be the current futures price right here. And then what we usually do, what you usually see, is that just like with the stock price, it's usually something, the up price is something times like some proportion U times the current F. And if we make those substitutions, then we actually see we're just going to divide everything here by F, and we're just going to get a 1 here, right? And that is the same thing you get if you had the other one and you put delta equals R. That's okay. You could totally do that too. And then we have a question: is the forward price an estimate of the stock price? Not necessarily. It's kind of like the fair price that, I guess it's sort of like you're kind of thinking that the stock price will be that in the future. Yeah, I guess you could think of it like that. So yeah, good question. Okay. But this might explain this formula here with the P star. It's just 1 minus D over U minus D. Yeah, so it's just because the forward price was the thing that was there in the for the stock price too, for the stock P star, same thing. The nice thing is that if they give you volatility, you get the same P star, which is cool. Even though P star looked different here, you can use the same formula with volatility to get the exact same number. Totally fine. Good. And then this actually a question: does this future relate to a futures contract? Yes, it's actually, this is a futures price contract, but you can actually talk about a call or a put on that futures price. So it's actually maybe a little different because you're not actually going long in the contract or short in the contract. You're going to be talking about a call or a put on that forward price. Okay, and then a question about volatility. What volatility? Well, they'll always give you the volatility and the rate of return and everything on the original stock. So this is actually stock volatility, even though it's a futures. Totally cool. Totally fine to do that. And like we had before, we talked about the up and the down position was really just the forward price, like up 1 standard deviation and down 1 standard deviation. So we could actually take the forward price, which was actually just current, based off of this, it's just current price, E to the sigma squared roots of H, current futures price, E to the negative sigma squared roots of H. And if we thought about this in terms of like, oh, what's the U and what's the D? Well, this would be U times F, D times F. And I could cancel the F's, and that just tells me that U is just this part. And D is just this part. So that's why the U and the D are going to be different for a futures tree versus for a stock tree. In the stock tree, they talk about the forward price tree or something, because it is kind of talking about the forward price, but forward price of a stock. So we had the U to be E to the delta minus R H, or sorry, R minus delta H plus sigma squared of H. But here for a futures tree, the U doesn't have that R minus delta thing. It's just the sigma squared of H. And again, you get that if you just plug in R equals delta equals R, but we're going to see that there's going to be a problem here on the next page because of that. That won't really translate completely. Okay, but that hopefully that kind of explains that. So this here, it's going to look almost exactly like the other one. So again, it's a future. So we're trying to find out what's the price, the way to replicate this futures payoff of the option instead of, just an option on a stock. You want an option on a futures, but that's okay, totally fine. The cost will be the same sort of thing, plus, payoff, have the same signs and everything, right? So the cost, so here's the only difference. The cost for a futures contract, right? It's a forward contract. So the cost is actually 0. Even if I buy 1,000,000 of them, the cost is 0. I'd probably have to put some money into the margin and stuff. So I might not be able to do that, but it doesn't actually cost me anything. It's kind of like a forward contract. The payoff would be, well, delta times, and then I guess here, if it's in the up position, kind of like if this was the stock in the up position, since it's a forward contract, or basically like futures contract, forward contract, it's just going to be the up position minus the current or the early forward price. And in the down, it would just be delta times D minus F. So this is the big difference because it's not a stock, it's a forward contract basically. The payoffs will be different, but the B will actually still be, BE to the RH, BE to the RH. And this should be the value in the up position, the value in the down position, same sort of things. And then I'll be able to solve for current price. But the big thing is that, well, because this payoff was different and the cost was different here, because of that, well, I'm just going to have a little bit different thing here. This is delta times that, and this is delta times FD minus F0. So you want to kind of think of it like that. F is like F0. And interestingly, if I solve for B, or if I solve for delta, I get almost the same thing, except here, there's actually no e to the negative delta, h. So that actually goes away, but the other part remains intact. It is change in option compared to change in price. So this is the part where I was like, it's not exactly that you just put R equals delta, because here actually delta would be 0, right? So it's like, it's not, doesn't quite translate there, but that's okay, as long as you kind of remember this part. And then the interesting thing is if you solve this and you solved it for B, you'd find that it looks almost exactly the same as the other one, except that there'd be this plus delta F0, or as we're writing it here, just delta F. Weird, it's just a weird algebra thing, but it works. Okay, but remember that whenever we do like a futures contract, our payoff is just going to be sort of like the difference between the original price that we thought was going to be the futures price and then what it currently is, right? Whenever we do that, when we market to market, that's exactly what we do. We're just like, oh, we're just going to pay the difference. So that's kind of why we had those there. So I haven't seen too much of this on an exam, but I just thought that this would be a good kind of question. Is our last one where it actually asks us to find this. Okay. Because it's not something that you probably see. It might be on your formula sheet, but maybe not. But just remember that the B actually will have plus this delta F if it's for a futures contract. Okay, and again, just want to give you kind of some more advanced stuff here. So what do we have here? All right, a current 1-year forward contract has continuous dividends on a stock with continuous dividends of 3%, has a forward price of 102. Okay, so the forward price is 102, and in 6 months, the forward price will either be a 110 or a 90. So Now, interestingly, that this is for a 1 year forward, but the tree is all about 6 months. Okay, that's okay. It's all right, no problem. So the current forward price or futures price, same thing, is 102, and in a year, in 6 months, it could be either 110 or 90. So that is the forward price or futures price, same thing. And this is 6 months. So they said if the risk-free rate is 6% continuous, determine the number of futures that need to be purchased and the amount borrowed or lent in order to replicate a 6-month 105 strike put on the futures, on the 1 year futures, but it's a 6-month tree, right? And that's okay. It just means that once you get out to this point, you're gonna, if it's a put, it's an option to sell a contract for a certain price, and that contract still has 6 more months to go outside the tree, but that's okay. But at any rate, I want the put with strike 105, but we don't have to really worry too much about it. Put in the up position is 0, put in the down position is what, 15. And so I'm just going to think of my delta and my B. And my delta is, oh, actually it's super easy on this one. Change in put, 0 minus 15 over change in futures, 110 minus 90. Was that 3/4? So negative 0.75. So actually that means I need to short 3/4 of a future. Now, it won't cost me any. I could short 1,000,000 futures and it won't cost me anything. But in order to replicate the exact payoffs that I'm looking for, the 0 and the 15, that's what I would need to do. Okay, and then the B is just e to the negative r, 0.07 over 2. So it's just a 6-month tree. So I got that. And then times, well, the thing that I would normally do, 110 minus 90, 110 minus 90. And then, yeah, kind of the crisscrossed values there. So I'm going to have 15 first now and then 0 second. That's kind of how I always did. But then plus negative 0.75 times the F0, 102. So let me move that over here. Okay. And all right, compute this out. Oh, I already got it here. So this is actually 5.7936. And interestingly, if I did the V equals delta S plus B thing, but in this case, it's a forward futures contracts, I could do delta F, but these are all just going to be 0, right? The cost is 0. So this will actually be 0. And so B is the price. This would actually be the price of that put. They didn't ask that, but that's okay. But what they did ask was how much money we'd have to borrow or lend and how much we would have to purchase. So we would actually have to sell or short 0.75 futures contracts. And we'd have to go long $5.79. Long is lend 579, which is basically the same as paying, right? I'd have to pay $5.79 to do it, but perfect. All right, so okay, well, man, some tough stuff we did today, but hope this helped. And yeah, I'll stick around for a few minutes. You got some questions? Otherwise, I'll see you guys tomorrow. Tomorrow's a good day. Log normal distributions. Oh, such a great one. So, all right, I'll see you guys then.